Welcome back to the stream, everyone. So, this is going to be, I feel kind of monotonous already just announcing what the stream is about, but we're still working on this robot, but you can see the light at the end of the tunnel. In fact, last night I finished the CAD. I mean, there might be bug fixes or whatever, but it's basically done. Basically finished the design for this giant complicated thing. And so I've got the parts 3D printing, and the last couple of parts to print to get a single winch really fully assembled are just kind of the cosmetic pieces, the frame, and a new version of this wall mounting bracket that fixes some problems. So we've got most of the parts, so I'm a little behind on assembly at this point, so I figured on this stream I could mostly just be putting this together, which might not be the most exciting stream, but it is something I need to do, and maybe some of you want to watch, and you're certainly welcome to ask questions and bug me while I'm doing it. So I started taking this partly apart so that I could reassemble it. Well, let's see, what was I actually doing? I wanted to take this top piece off. Yeah, I just wanted to make sure that all of the bolts that needed like glue or Loctite on them were properly set up. The assembly order on this thing is a little bit crazy. Like, you can't actually access all of the fasteners when it's assembled. There's actually kind of a specific order you have to put it together in. So some of these fasteners under the spool, I kind of wanted to try to, so the ones that are designed to just stay in place, I wanted to Loctite them a little bit. And these nuts that want to just stay in position so that I can then attach bolts in on the other side, I think I just want to put like a little dab of E6000 glue on top of them just to hold the nuts in place. And then the other reason I took this apart is I needed to put some epoxy in. Well, now I can't turn this over because I just put these nuts in, but there's basically the nut that's holding this big ol' M8 anchor in is, like, I'm not super confident that it'll just stay in place via pressure when the other end of this is loose, because I designed like a really tight-fitting compartment for the nut to fit into, and then tightened the shaft into that to kind of wedge the nut into the compartment. And so that kind of holds, but not as well as I'd like, so then I just filled the whole compartment with epoxy. So that's on the other side, but while I have it on this side, I think I'm just going to put a tiny bit of glue on top of those nuts so they don't move around. And then while that glue is setting for a few minutes, we can take a look at CAD or clean up these other 3D prints. Because these two blueprints, these 3D prints that happen to be this particular shade still need some cleanup. And this one that I've already got some parts in still needs some cleanup too. So this is E6000. It's basically like if hot glue and cancer had a baby. That's a little flippant, but yeah, no, it's a really strange stuff. Like, you can use it a lot like hot glue, but it's also, because it doesn't rely on heat, you can get it into tighter spaces than I'd usually be able to get a hot glue gun, which is what I'm doing here. And I think I just totally slimed the side of the nut that I didn't mean to. Let's try that again. I can also try to get a better camera angle for this. These toothpicks were a gift. I don't think they were... I think the person who gave me these toothpicks probably assumed I was going to use them for food or, you know, like culinary dental purposes. But yeah, E6000 is really strange. I've used a lot of it, and I still am not entirely sure what it's made of, because, like, I've looked up the MSDS and stuff, but it wasn't very specific. Okay, I want to grab a nut that isn't covered in goo. Oh, hey, Tuco. my goal here was to put the nut in and then just slide a little bit of glue down the edge of that hole just to keep the nut in place. And this E6000 is viscous enough that I'm hoping I can do this without getting it in the threads, but it's also pretty soft, so it's not going to create kind of an overly mechanical constrained situation. It'll just keep the nut from falling out. That was also, so this is one I prepared earlier of a completely different size, but same idea where I had a hexagonal hole that tightly fits the nut, but I just don't want it to fall out. So actually, I wonder if I can use the same strategy. So to put this in, what I did is I put the nut on the end of a piece of threaded rod, and then I just kind of gooped up the edges of the nut with glue and then stuck it in there, and then took this out and let it cure. Maybe I can do the same thing if I have a really long M3 screw. I mean, these M3x35s are the one that I'm actually using, but they've come in from the other side, of course. Oh, that'll do for there. How about for here? There's plenty of room. Cool. Let's use that strategy. Now I can just, this is like the ghost snot from Ghostbusters. And so this glue is not at all structural. This is just to help me not have to be losing these nuts all the time. Let's have some fresh glue from inside, because that stuff's already started to get tacky. Great. No. Okay, apparently I had a lot more screw turns to go. Okay. I don't know if that was enough glue, but it probably was. It shouldn't take much. I'm just trying to hold it in there. Keep it from falling out due to gravity, basically. Huh. Did I already glue this one? No, it's just a tighter fit. Okay. Well, now I have this puddle of glue on my desk that I might as well use. Whoops. Luckily, this stuff actually is not too hard to get off when it's dry. It just kind of pulls off. Whoa. Oh no. This is perilous. I am trying to keep this from falling over. Okay. Got it back on the screw. Let's turn that the correct direction. Okay. Yeah, I do end up leaving a bunch of glue on that very top edge, which is inconsequential. I just hope there's enough still on the nut. It's probably fine. Yeah, look at that giant mess I'm making on my desk. Oh, good question from Vince on how long it takes to set up. I think it's one of those like full strength in 24 hours, but it gets pretty tacky within a couple hours kind of situation. And the working time is actually not that long. It's only like 5 or 10 minutes. It really depends on how thick a layer you use. So for something thin like this, it would actually get fairly tacky soon. I think it cures due to a reaction with the moisture in air or something like that. But yeah, it's the kind of thing where like we can just leave it for a few minutes and then I'm not going to worry about the nuts falling out just due to gravity, because it gets tacky really, really quickly. Yeah, I'm just kind of snotting it onto the edges of these nuts. Oh, delicious. Oh no. I hear you, Tuco, but I can't really move right now. Ah! Ah, that one is now too covered in glue. Let's get a fresh nut. Okay. I really would have put something down on top of this anti-static mat, but now it's already a little bit too late, and I'm just going to have to pull this all off once it dries. And avoid it until then. So these 6 nuts hold what I've been calling the top bracket on. So this, well, if I zoom out a little, you can maybe see it, this neon blue thing over here. It's still kind of mostly out of frame, but it acts as a mechanical anchor for the shell that covers the entire thing. It also, perhaps more importantly, it holds the rollers and the measurement capstan on the top of the winch. So those are the main load-bearing things that it has to take care of. So kind of right between these screws, there's a couple of rollers that the rope has to pass through. Oops. Okay, I'm hoping that works out. I think I've gooped up everything that I care to goop up in this orientation, so let's let that cure for a few minutes at least. Put this lid back on. And let's go to the CAD and I can show you what all we have total. Maybe a brief detour through the 3D printer. Oh, interesting. Vince reports streaming issues with YouTube, and the Twitch stream is down? Is it? Oh, maybe it is. What's going on here? Oh, that's embarrassing. Maybe I will have to come right back and fix that. I don't know why YouTube is complaining about this. I think YouTube is doing the thing again where it's giving me an error message about the video's container format, but I can't really tell why, and yeah, it seems to be streaming over here. But yeah, I don't know why I wouldn't be live on Twitch. I'm supposed to be live on Twitch. Don't think I have a good way of debugging that right now, unfortunately. Yeah, I don't know why that wouldn't have just worked. I'll have to go check some log files later. Ah, that's frustrating. You can already see kind of a pattern of where the cord is wearing on this roller a little bit. Man, that is disappointing though, because I don't want to leave anybody who's following on Twitch out in the dust, you know. Oh, thanks for the chat post, electric crowbar. Yeah, well, I'm gonna try, oh, is this against Twitch's policy? Am I finding another way of violating Twitch policy? I must have missed that part. Well, if it's against their policy, then whatever, they can ban me. I'm gonna keep streaming. So, let's get this camera out of the way. Anyway, I hate streaming politics. Here's the chat, or here's the CAD. So yeah, happy little winch bot. So I have not started printing this shell yet. You can see it looks like it's pretty big, but it's not that bad of a print. Each half is like a 15-hour print, which is not terrible. So it's designed to print without support, which is a little bit weird around like the bolt holes and the LED strip channel over here, but I think we can manage. But adding support material would have just made this a significantly bigger print, and it would have messed up the surface finish of these angled areas. So a lot of this was designed with printing supportless in mind, so that's what set the angle of these edges. That's partly what influenced the design of this lock that holds the edges together up here. These shapes are designed to constrain the two edges so that they, like if I have screws kind of pressing them together in the axis that's up and down right here, then these little tabs will kind of hold the two shells together in their in versus out axis, like along the radius. That's what that's for. And I'm hoping that the amount of clamping pressure from these 4 screws kind of outweighs the tendency for this whole thing to just flex enough for these little teeth to stay engaged. That's like 4 millimeters though, which should be plenty. Anyway, so printing those next. If we take that off. So without the shell, this thing will still work pretty much the same. The shell is optional. You'll notice these LED strips that I added are mounted to the shell. So there will be like a little bit of wiring in the interior of the shell and like a connector, but that's all totally optional. The LEDs are just bling that you don't need to add. The actual mounting happens via this bracket back here. So there's actually a little thumb nut back here that you can use to capture that M8 thread that comes out of the back of the bot. And then you also need a way to retain kind of all that force that is pulling up on the bot through the rope that attaches to this pulley. So to deal with that force, I'm using this as kind of a lever fulcrum, and then actually dealing with it down here. So this is what should actually keep the bot from just kind of tilting up off the wall due to the force of the robot's weight on the other end. So if we look at just, let's turn all this stuff off and just look at that piece. So that's assuming we have like a piece of wood, like so here's a 2x4. And then this does provide a way to angle the robot slightly, like up to about 20 degrees or so. So you can just rotate it, line it up with the ceiling pulley, and then tighten this down again. And then to get it off the wall, you can just loosen this and then just like lift the entire... Well, actually, there isn't quite room to lift the robot up first. What you do is you loosen this and then rotate this away from the bottom, like kind of do like that motion, and then you can lift it out through that slot. That might be a little easier to demonstrate once I have the physical parts. But anyway, that mechanically attaches to these two pieces. And then there's just rollers, more rollers, electronics, cat. And so we've tested this top piece, and it's already pretty much assembled. I'm just reassembling it with a thread locker and glue and stuff. But this bottom piece is all new, so I think maybe the next step is to clean up these two 3D prints, these two blue pieces. So I think we were designing these on the last stream, and now they're all just ready to go together. So this side holds the microcontroller circuit board, provides an Ethernet jack accessible even when it's fully assembled. This is the USB jack for programming firmware, which is accessible with the shell off but hidden with the shell on. And then on this side, this is the power electronics. So AC inlet, a little bit of room for wiring, big old capacitor to store the DC, then the motor driver. This is the fairly beefy, like 40 amp rated H-bridge, which I've also soldered the DC-DC converter to, so this is where the 5-volt supply is coming from. Heatsink, and then this is the big old 24-volt mean well supply. And room for the mushroom e-stop button on the front. And that got a little bit of extra insulation just to try to keep the 120-volt wiring away from all the other metal work. So the high voltage wires for the e-stop button will go in through these little holes and be mostly shrouded away from the like metal gearbox and the motor and that kind of thing. So that's what we got. Gonna have 4 of these. It'll be a happy little family of Ethernet robots. Oh, this is such a mess. This puddle of glue is not fun. Clearly it goes with coffee, right? Oh yeah, YouTube seems to be going back and forth between telling me there's an error and not telling me there's an error, which is interesting. And at this point, I don't even know whether the Twitch thing is a problem on my end or their end. The way it works over here is I stream to a local Nginx machine, which then streams to YouTube and Twitch and any internal stuff that I have it going to also. Okay. So I've still got just a lot of printer trash on this one. Where are my good cleaning tools? This one's not bad. Let's go. I don't know what to do about that then, because I was kind of enjoying YouTube, or kind of enjoying Twitch, but I don't really want to not stream on YouTube, because there's such a good electronics community on YouTube, and so I don't know. I mean, what do they qualify as being the same stream? I mean, could I just put some, you know, like rotate by 2 degrees and then stream to Twitch or something? I mean, my other plan was to basically just have 2 separate streams so that there would be like this main live stream and then the Tuco Flyer stream. And that's still the plan, but I think Tuco Flyer might be not a Twitch stream, it might be like a Let's Robot stream, because they've got a separate platform now, which might be a lot more ideal than Twitch. So I don't know, man. I mean, Twitch is kind of nice. It's got an alright community, it seems, and I like the clipping feature that lets you just make a URL for a video, but if they're shutting down my account for also streaming to YouTube, then that's not something I can deal with. I don't know if that's the issue yet. It might just be a random network problem, but it's a little weird. The other thing is YouTube actually has much better quality streaming than Twitch. Like, they offer transcodes for everybody, and they let you send pretty much as much video bandwidth as you want, whereas Twitch is much pickier about that. Which, you know, is the effect of Google subsidies and all that, but is a thing to consider maybe. Oh, okay. So then Robert in chat is asking where specifically Twitch disallows this because they're not seeing it, and in fact there are some services like yeah, Restream is one that I looked at actually. I decided to do it myself because I figured well, actually for a while I was trying to do it using using like an EC3 or EC2 node, like in the cloud, but just with like FFmpeg. And that was alright, but I wasn't transcoding. So yeah, I was looking at Restream. I thought about using them, but when I ended up finding out that I could get cheap fiber here, then I had the bandwidth to do it myself here. It still kind of blows my mind that I have gigabit fiber here. Internet bandwidth is just one of those things that's just so different in different parts of the world too. Like, I'm sure some places, like, that's not that uncommon, and then some places like 10 megabits is pretty outstanding. I'm used to more like the 10 megabit kind of internet, so going from that to gigabit was pretty awesome. And that means I can stream to several services from here. But yeah, without just like fiber internet, then the bandwidth is quickly limitation. So before I had that, I was streaming to the cloud, and then I think I was using a similar Nginx setup there. Just didn't have to run it on my cable modem. This was a complicated enough print that I ended up getting a bunch of weird little like surface boogers on it, which aren't really a problem. I mean, I don't really have to clean this stuff off for the most part, but I mean, there are some areas where there's a mechanical interface where you want it to be clean, but I'm also cleaning a lot of stuff that is more aesthetic. There's some support still in there. I was streaming my like proto Tuco Flyer, like the camera that isn't attached to the robot yet, but that account got temporarily banned for not being interactive. And it was also because I was streaming in the IRL community without realizing why that would get me banned. But I haven't set it up since then because it seems like it would still, like I might be flying lower under the radar, but it would still be likely to get the account banned if I had it pointed at my cat, but not actually interactive, so not actually taking chat commands to move the camera around yet. And so I figured I would just wait until I actually had the chat bot set up so that it was moving the camera. But I might just skip Twitch altogether because Let's Robot seems like a pretty neat platform for this kind of thing. And it, like most of the robots on there right now seem to be streaming with like pretty low quality video, which is one thing I was worried about, but I think there are some ways around that, and I've been talking to the folks there. So I think maybe I could use their platform, but I still have higher quality video streaming. Because it is, after all, a camera robot, so it needs to have good video. That is a big chunk. I hate cleaning brims out of all these little holes. That's my least favorite part of cleaning up a 3D print. Oh, you know, I wonder if a deburring tool would help with that. There's that. Okay. This may or may not work, but I'm going to see if a deburring tool is something that can help with these. Oh, man. That is beautiful. Wow, that will make nice wide air holes that don't have junk that restricts the flow. That's perfect. These are the motor cooling vents, basically. Yeah, so if you want to just remove the brim, you'll need to be gentle with this tool, but if you want to also take off a little material, then it's actually pretty amazing. Oh, that's great. Okay, well this half seems to be mostly clean. Oh! There are all these bolt holes that are full of support material still. Never mind. I need to push this out. Oh, am I gonna just want to clean this out with a little drill? I don't know. Or a stick. Ooh, stick might be the right tool. I can just like pop that out with a stick. Robert was just mentioning in chat how many chat clients they've opened, like 6, and yeah, I was getting to that point again recently because I guess I'd managed to avoid using Discord until recently, but then somebody invited me into a Discord, and I was like, okay, oh, it was for the Let's Robot stuff. They use Discord because, of course, it's more of like kind of gamer tools rather than programmer tools, but there's so much overlap in that culture. It's kind of interesting where the fuzzy lines fall. I wonder if I can use this effectively on this edge too. It is difficult not to take off more material than you want with this on the plastic, but it is fast. Yeah, that is nice and fast. I will probably use this on all the parts that aren't delicate. It does make very short work of the brim. It's a little thin layer of plastic that I usually print to keep parts held down to the build platform. And you can use it to add a slight chamfer, which in some of these cases is actually kind of nice. I think right there, I just want to use the knife. Oh yeah, I appreciate the help with announcing all the chat crossovers. Because yeah, we have this Gitter chat that is kind of, I don't know, I kind of cringe at calling it the official chat, but I guess if you want to call anything official, there's that, and it's mostly just where we can hang out even in between streams. But, you know, it's not ideal for everyone. It's a little harder to use on mobile, and if you don't already have an account, it's something else to make an account on. So, like, I'll still be looking at, like, the Twitch chat and the YouTube chat, but it isn't something we kind of have quite as much of a community built around. Okay, I think I'm happy with this. Oh, I was going to do this hole too. This is where the actual button mounts. And that will help it be a little more circular. Okay. That is a part I'm pretty happy with. So this needs a little bit more prep. Like, there are some brass thermoset inserts that get put into these holes. Let's make sure these are flat. The little pillars on top need to be flat because they press right up against the circuit board. So any boogers on there are going to be important to get rid of. There you go. Oh, some good questions from Sam, who asks, am I printing the outer shell? And then Charles asks if I'm printing an ABS or PLA. So I'm not quite printing the outer shell. I think the shell is next on the printer. Right now I'm printing another wall mount bracket because this one was almost right. Oh, is this not quite focusing now? This one didn't quite have a wide enough countersink here, so the screws stick up and don't make this flat. So this is not actually usable other than as a test fit for these interfaces. So I'm printing another version of this, but next on the printer is going to be the shell. I was also waiting to get some transparent PLA in the mail because I'm low on that, but some of that should be coming in today. And yeah, all of these pieces are PLA. My printer as it's set up right now isn't really good at ABS, but got plenty of PLA. Alright, so the other half is over here. So I've already started fitting some of the electronics in here. I can take this out, and I should. This is the motor driver. This is the 120 volt like IEC inlet. I don't actually know how easy this is to take out. I didn't really intend these to be easy to take out, but I intended to have just barely enough room to work on them once they're in. I'm curious though, I wonder how hard this is to take out. It's probably not worth it though, because it is a very snug fit. Yeah, I think I'm just going to leave that in. Okay, let's clean up around it. So the ideal way of doing this is to solder the wires to that connector before you install it, but I was interested in test fitting the print ASAP, so this is how I did this particular one. But that's fine. I think there's enough room to do the wiring. And this plate here is just to give me a little extra insulation between the high voltage and the low voltage circuitry. This is a capacitor. The leads point that way, so the capacitor is going to be kind of glued in place here, and then the high voltage will be in this box. And there's a place for a zip tie right there, which may or may not actually end up being big enough. Oh, somebody's making curry and it smells great. Yeah, the transparency should be interesting. I expect it to be kind of like a frosted look where you'll be able to kind of see the overall colors and some of the lighting effects through the transparent PLA. But then you'll be able to actually see the mechanism just a little bit through the ventilation slots, because there will be plenty of slots on the cover. So it'll be kind of a mix of getting glimpses of the stuff moving and the bright colors, but having most of it diffuse. So like the overall exterior shouldn't be actually as like quite neon pastel as the inside of this project has been looking, because it'll be muted by the actual enclosure. These little plates of support material like to hide out. So I designed this to print with relatively little support material. So you can see that like a lot of the areas that need support were optimized to, to not really extend that far in the XY plane, so that I didn't have to build up that much of the print bed with support as I went. That's another place for a zip tie. All of these holes are for zip ties, for wires. That one's for mounting the power supply. It's a little tight in there. This part is fun. I want to make sure the camera's ready for it. Oh, that feels like just the right tool for that job. That's great. I mean, I guess brims are kind of like metalworking burrs. Trying to get this edge by going that direction, but going that direction seems to just want to dig really deep into the plastic, which is not what I was into. So I probably should have just gone with the knife to begin with. Yeah. motion, isn't it? There's a little bit of support material left in here. Probably isn't a big deal though. There we go. That's an actual wall. And stick. My stick is not lasting. I think I might. You know, having a little piece of metal for poking would be really nice. I don't know if I have something like that handy. Get a fresh edge. All right, I think that's fine. Okay, I think this is as clean as it needs to be. So, assembly. Is this glue mess? This is still drying. Let's try to avoid putting my elbow in that. Okay, so here's a different mess. This has wires coming out of it all over the place. So the relevant part of this is that it isn't really possible to take the motor off of this blue plate once they're assembled without destroying the gear, because that just hammers on. So this is designed such that with the motor installed, you can assemble this in two pieces. It's still super weird though. So these two pieces bolt together with bolts, two at that side, one at the back. So it works like this. So you can see these go together, 6 screws go in here under the motor. Those will be a little tight. There should be enough room to get those in with a ball driver, but that's going to be a little bit annoying. And then put the long screws in to keep this all together. You'll also notice that before all of that happens, the e-stop switch has to be in place. So the e-stop switch has to be wired and in that compartment, and then these two pieces go on the motor bracket, they get bolted to each other, and then after all that, then you can tighten the front nut on the e-stop switch. So that's the plan for this portion. Which means the next thing to do, oh, and there's already lube on the gears, which means now there's already lube on my fingers. Wonderful. I was trying not to touch the gears. Good time for coffee, right? So yeah, here's one of the e-stop switches. Actually, Big Clive, who recently assembled one of his kits and had a lot of fun with that, he also did a teardown on not this exact button, but another one from the same series, where it's basically just a really common modular kind of, equipment button that you can find cheap on eBay and AliExpress. And they're clearly not made with just a huge amount of material. They're pretty light, and they're not going to take being hit with a sledgehammer or whatever. But for what they are, which is a pretty basic switch, they actually seem to be made just fine. You can even see the contacts through these windows. And it's got a normally open side and a normally closed side. This is the, well, so right now it's in the off position, but there's on. So this is normally open. This is normally closed. And so you push it, the contacts come apart. And so Big Clive took one of these apart actually, and it seems like it's fine. There's even like a little wiping mechanism like you'd expect, so that the contacts move side to side a little bit during their motion. So this red side is the one we're going to be using. So when the bot is on, these are connected. When you push it, because something went wrong or one of the bots is on fire, whatever, you push this button and it separates these contacts. It's also got two contacts in series, which is kind of nice. So if it separates either of them, then you break the circuit. So the way, oh man, that curry smells great. So the way this goes, so I'll be using these terminals, ignoring these terminals. These terminals will go at the bottom here, where there isn't that much insulation, because like this will be pretty much facing, that's like mounted right up against this axle basically, which isn't much metal, but like basically if there was a fly wire down here that wanted to short out to something nearby, it might short out to that axle, which itself is isolated, but just to avoid that, I am using the section of the switch that's at the top of this box, so the connections will be pretty well contained with plastic, and there's enough room for that wire to route over here up out of this hole, and for the corresponding wire on the other side to route out of its hole. So that's the plan, at least. It is a little annoying how specific the assembly order got for this project. I think a lot of that is because of how I designed like the upper portion of this robot before designing the rest of it. And in a second revision, I'd probably modify the brackets a little bit, but I think for what this is, which is a long drawn-out prototype, this is more than enough. Wow, I just spilled coffee on myself in camera. Luckily you didn't actually see it. Anyway. So we need some wire for this. I sure have a lot of 20 gauge wire. I think I've got some 16 gauge silicone wire, which should be awesome for this. What is this? Yeah. Automotive grade silicone, 16 gauge. That's the ticket. Is the chat stuck, or have people just been really quiet? Let's refresh the chat. Oh, I guess it was stuck. Great. Glad I unstuck it. Oh, Mikkel suggests building a disc sander. I've got a little, like one of those little handheld orbital sanders, but in my experience, sanding PLA just kind of like makes a mess. Like it heats it up and turns it into kind of a furry grossness that's hard to get off. I'm gonna overdo this a little bit. Oh yeah, Dylan asks if those are the kinds of switches where you can replace the sides. Yeah, you can. They're totally modular, and you can stack. So you can replace each of these sides. You can also stack additional poles on behind them. Oh, yeah. So Mikkel, I have a sander like that. It's not, in my experience, been useful for PLA. Oh yeah, I see what you were saying. Got to break both live and neutral by... Yeah, no, that would be preferable. Maybe I'll do that next time. I mean, I was at first not even really sure whether I should be breaking the AC or the DC. The main reason I'm breaking the AC instead of the DC is that I'm worried more about arcing on the DC side due to the inrush current on that big capacitor. Because if I ever disconnect that capacitor from the power supply and then reconnect it, then there's a chance to have a big arc. Whereas if that's just always connected to the power supply, then it ramps up when the power supply ramps up. Okay, so I want the red side. Oh, did I? That's right, you can't actually push it when this is unscrewed that far. There we go. Okay, let's just unscrew all this. And how did I want that to sit? I think I wanted the wires coming out this direction. I mean, basically this should be such that even if the wires were going to be like trying to melt together, there would be no path such that that would work. I think I want that to be on the bottom side of the screw so it doesn't try and come out. Okay. I'm going to give this a quick test with the ohm meter. Oh, where's my fluke? Okay, so this is not an ideal test for low resistances, but we can at least make sure that nothing is horribly wrong. I'm going to use the alligator clip lead on this meter. Okay, so we're reading no larger than 0.1 ohms with these just clipped to each other. Let's strip the other end of this. .5, huh? Whoa. Is that? That couldn't be real. Do I have a bad connection in my test setup? Because I could not imagine the switch being that bad. Is this? Maybe I should be testing this under some load. what just happened there? What state is it in right now? The contacts look like they're closed. Yeah, I don't know about that. Although, I mean, not all high current switches are designed to operate the same at very low currents like this meter is using for testing, so this isn't necessarily the best test to be using. Let me get like a light bulb or something and hook it up to this. I mean, if I totally don't trust these buttons, I could use them to switch something low voltage that just turns off the micro, but it seems better to just cut off the power. Like, the thing that I'm actually worried about is the switch, like arcing and sticking closed. But given the distance of travel when you're opening the switch and the wiping motion, those are like two things that seem like they would prevent the arcing, but I have really a dearth of good alligator clips right over here. So I'm just going to measure the voltage across the switch. Let's at least put these parts back on. All right, and okay, these are 6-volt light bulbs, not 24-volt. Okay, power on. 6 volts across the switch. Then, wow. Seriously? 0.2 volts? How is that even happening? It's going to be frustrating if these switches are not actually good, and yeah. Oh. Wow. Okay. Yeah, maybe this gets used for a logic signal. I'm curious if the other, well, I'm curious how bad this is on a different switch, like how much variation there is between switches. I've got a few of these. Yeah, this is much worse than I was expecting. Yeah, I mean, I might just use this to switch the 5-volt power, because that'll be really low current, and turning off the 5 volts, I mean, maybe even not the 5 volt, maybe I'll put the microcontroller into reset or something. But like just something logic level like that, so that, you know, if you have a problem with the motor driver or with the software or something, you can hit this. But if there's a problem with like the power supply, which seems unlikely, but if there's a problem with the power supply, then you have to yank the cord out the back instead. But yeah, this is not so great, is it? Let's try a different instance of this same model of switch. I mean, it's possible I could find a better made switch that fits in the same kind of mechanical envelope, but I would like to not have to reprint these pieces. I mean, it wouldn't be the end of the world. I could certainly do another rev, and especially if I didn't have to redesign that much of it, but this is frustrating. I mean, obviously I should have done this test before doing more of the design, but it's one of the couple of million things I didn't think about doing. I'm also using one of these switches as like a low voltage contact for shutting off my UPS in the server rack, but I think it's probably fine for that, because that's just a 24-volt logic signal, basically. And yeah, I could have a relay and use this to switch the relay, but that seems unnecessary. This one's better, but not by that much. I was asking if I can get the contacts on the side separately. I don't know if these are compatible with like name brand stuff, or if they're just kind of something you can find all over the place. But I think I'm probably just gonna have to use this for lower voltage stuff and not use it for the mains. That's fine. I mean, not use it for the mains, also not use it for the high current 24 volt, because I don't think it can handle either. But I mean, this seems fine. This is sufficient for a logic signal. Oh yeah, Mikkel says they suspect that this might be a copy of a name brand part. Yeah, maybe. I did go shopping for different varieties, but the other kind that I saw, which was commonly available and not as cheap as these, but still also not super expensive, were based on kind of the normal like momentary like leaf switch kind of things in an enclosure that turned them into mushroom buttons. And those seemed better, but also it was hard to find one that used like a contact that seemed made by a brand that I'd necessarily trusted, so it seemed like it would also be another kind of hit and miss kind of thing. So, I mean, the most straightforward thing to do with this might be to use the normally open contact so that when you press this, it holds the microcontroller in reset. Although honestly, it would be nice to interface this directly with the motor drive signals and have this like cut power to the motor driver. I mean, if I just cut, I don't know. If this holds the microcontroller in reset, and there's a, I mean, I think there's already a pull down on the enable inputs for the PWM driver, but I'm going to double check that, and assuming there are pull downs on that input, then holding the microcontroller in reset will turn the motors off. Not quite as foolproof as I'd like it to be, but I think it'll be fine for this prototype. Okay. Well, in that case, I can attach much lower gauge wire to this. It's kind of a disappointment, but it's fine. Oh, I should decide whether to use the normally open or normally closed side though, shouldn't I? I mean, I could just attach it to a GPIO and have it be something that's tied into the watchdog loop, which is something I haven't written yet, but is like one of the next things to write in the firmware. But directly resetting the micro seems more reliable than that. Yeah, okay. Maybe I'll use the normally open side. I don't like using the normally open side, though. That might be the easiest thing to do right now, though. Wires. What is this? I'm just going to use 20 gauge. It's not that much smaller, but I'll at least keep these wires intact, I hope. Matthew is asking why not drive a relay with it, because then I would need space for a relay. And I would still be running higher voltage into this unless I also had a power supply that was active when the main power supply is not. I'm still trying to think, is there a way I can do this more reliably than using the normally open line to pull reset low? Because I would really prefer to use normally closed so that I can easily... I mean, I guess it really, the reason it bothers me is that it makes it harder to notice if there's a problem with the e-stop button. You have to like get in the habit of testing the e-stop button, but I figured that's something I'd be doing anyway, so maybe it's not a big deal. And there are plenty of ways to trigger like a software e-stop situation, like yank the Ethernet cable, or like pull on the nylon cord, honestly, because then it'll just notice the force is out of range and stop. I mean, it's nice to have a button for, oh geez, the microcontroller is on fire and the motor controller is getting 5 volts anyway. And that would be nice to have a button for. I mean, another possibility is to use this on the normally closed between the 24 volt supply and the 5 volt DC to DC converter. Oh, did we just lose the YouTube stream? Oh man, we also have spam bots. We don't want those. All right, well. Let's just take a look at the motor driver and make sure it has pull downs. Assuming the motor driver has pull downs, I'm really tempted to have this be normally closed, and when you push the E-stop, it cuts the 24 volt power to the logic side of the circuit, which is low current, so I don't mind, like, it's not going to cause arcing, and it's got enough voltage headroom that losing like 1/10 of a volt in the switch is no big deal. Yeah, let's take a look at one of these. Lena's asking if I'm streaming on Twitch. Apparently I'm not. I'm supposed to be, but I don't know why it's broken right now. And it just seemed to be, and since I'm streaming, I haven't had a chance to take a look at it. Okay, so let's take a look at the enable signals. That looks like a 1K pull-down resistor. That's one enable. Oh, that was current sensor. This is the enable. Yeah, so that one and that one. And this side is definitely ground. Yeah, 1K pull downs. So that means, oh, and but that's on the input side of. So the way this works is there's a pull-down resistor on these inputs that come in from the microcontroller. Then there's a buffer here, which I assume they wouldn't have any resistors on its outputs, but basically the clamping diode, like, if the overall 5 volt rail drops, then the outputs of this chip end up having to drop also because of those clamping diodes. So I think we're fine. I think if we just cut that power, then we're sure that the inputs to the motor driver also go to 0. Yeah, okay. Well, I'll wire this. Let's go back to wiring this switch as normally closed. So we're still using the red side, same as in the test. Which is good because now we're separating a part of the circuit that we actually need, which is how I'd prefer this to operate. Okay, so same as before, but now I'm using 20 gauge wire since I'm not as concerned about it being thick. Since the switch certainly doesn't ever need thick wire running to it. It won't help. Yeah, I still don't know why the Twitch stream is offline. It could just be something random is wrong with my setup here, or it could be they banned me again. I have no idea. Okay. So... I'm kind of not looking forward to those 6 bolts that hold this onto the motor frame, but maybe they won't be so bad. Let's make sure this will fit. Yeah. So the plastic goes between that gasket and the yellow thing. There's a lot of room on the sides there. I mean, probably not quite enough for a completely different style of switch, but you can kind of see how that goes together. So we're using the contacts on the other side. And then it doesn't make sense to tighten that until these are bolted together, but basically that's how it'll work. Mikkel's asking about the wattage of the PSU. Yeah, I know 16 gauge is like way overkill for everything I'm doing here. It's just the nice silicone wire I had that was bigger than 20 gauge. Most of the wire I have in stock is 20 gauge for silly reasons. Anyway, that's fine. We can start attaching that to this. Oh yeah, the other thing that's going on here is we've got these wires. Oh, you know, I really can't put this on until I get the 2 halves of this frame reattached, so maybe I've got to take a break to do that. Because that's right, we were waiting on this to glue, and it should be glued at this point, or at least enough to not destroy itself. So we've got to get that put back together so that we're done with these holes, and then we can cover them up. So let's go back to this side. All right. The wires have to hang out together, and there's a roller that goes in here. Here it is. Is this thread locked? I should thread lock this. Not severely, but at least enough that I'm not going to worry about it vibrating loose. Where is my thread locker? Yeah, just a little bit. All right. I think that'll do. All right. So next, the frame gets assembled, like these two halves get connected together with the long threaded rods. And yeah. That's right. I wonder, I think this actually might be easier to do with M8 bolts than threaded rods. Ah, that's right, I ordered some, but I don't think they're in yet. Anyway, there are various ways to put this together. One thing I could even do is thread lock one nut onto this and then drive it in. So the way this side works, there's a slot that just kind of holds a nut up there. And so you can tighten the shaft into that nut and then put another nut onto this end. I apparently have some nuts that are a little bit smaller than the ones in my CAD model, and so I've got to avoid using those when I'm actually trying to fit this tightly. So there's that. And then ideally I would actually be driving the nut, or the shaft directly on the other side. I don't really have the proper tool for that, but I think if I grab this very gently with wire strippers, no, that's a little too wide. How did I do this last time? I don't think I quite have enough room to back a second nut against that. Maybe I just used my smaller pliers to turn it. Yeah. Okay, this is fine. I think this is how I did it last time. So I'm just turning this into that nut, which is easier now that I'm using a nut that's actually large enough. I think that's tight enough. And I can use the socket set to put the other side nut on. Socket. There it is. That's funny. Somehow I ended up actually requiring two slightly different sizes of nuts in this design. Because I had these smaller nuts, which I think are 12 millimeter. Yeah, this is not intentional. Because the 12 millimeter nuts are the ones I actually had on hand, and so I was using the size of this tool to gauge how much room I needed for access. But then the other end, actually I need a slightly larger nut because I was using a model from McMaster Carr. Yeah. Weird kinds of mistakes that I've not had before I started getting into mechanical design. What is going on there? That's not how screws work. All right, little cross thread. Much better. Yeah. Okay. That's how that goes. One more on the other side. This one is similar, where I have to put a 12mm nut, no, a 13mm nut at the top and a 12mm nut at the bottom. Thanks, past me. And it is really hard, like, when you just have a pile of 12mm and 13mm nuts on your desk to tell them apart. Okay, so I've got to turn this upside down and hold this in place. This part is just annoying because the nut keeps wanting to sink to the very back of the socket tool. Oh, am I forgetting to put the shaft in? That would be silly. Where did the shaft even go? Clearly my desk is now passing the level at which it's too messy to actually find anything. But it's like mostly covered with parts that go into this robot, so I just need to finish assembling it. Okay, so maybe I need to get this started. And then I can push this through. I don't know, then I can't really turn the shaft onto that next nut, though. I need to start with this off. And then put this on. Oh, that is really hard to hold in that little area below the load cell. You can see how this might be easier if these were just long screws instead of 2 nuts and a bit of threaded rod. I think I've got the nut on the other end. I've just got to give it a couple more turns. Okay. All right. That's nice and tight. So the frame is assembled again. What is rattling? I think there was just a nut stuck in there somewhere. Where was that? I don't know where that nut just came from. I don't think it was anywhere important. All the shafts here are still tight. I've still got nuts on both sides of the axles. Okay. So, next up is to put this top assembly on. This is a little easier to do when the cord isn't already on the spool. So I have to carefully avoid the wires for the load cell and then put this on through all of these holes. seems fine. Now, where in this mess is the wrench that I need? Oh, movie recording. Yeah, Electron apps are so heavy, it'd be nice if we just had one container that we could put them all in to share all the overhead. This is the moment where you hope it catches the nut instead of just pushing it out of place. I think that's right. Seems good so far. Oh, right. This already has a screw. Okay. Also not quite sure how I ended up with these screws that are just a little too big for this ball driver. Yeah, cross-platform UI dev is pretty bad. I mean, that's basically a position that you just don't want to be in. It's much better to just have different UIs for each platform, but then that's of course super expensive to maintain. And if it's like a niche app where you don't really have that many users per operating system, then that can just wreck your entire development process. So yeah, it'd be nice to have a better option. I mean, I've used plenty of the toolkits like GTK and WX and Qt. And yeah, they all exist, and they all kind of work. Man, the Servo AF is not having a great time with this. Yeah, I don't think cross-platform UI has ever gotten better. I mean, I was kind of interested in that problem for a long time, and it all comes down to policy. Like, it's all about politics and expectations kind of spreading across people's worlds, and cross-platform UI is just one of those areas where the expectations all start to meet and conflict with each other. I think these are all managing to grab their nuts successfully and not just push them out of the way, which is good. These are the nuts we were just gluing in just earlier on the stream. Cool, I think this is about done. I'm just giving it a final tighten around. All right. I also, as you can see, took off the old Encoder capstan because I ended up reprinting those with some better printer settings, which I think decreased the wobble, using concentric infill and making the borders a little thicker and stuff. So I'm going to grab a new Encoder capstan. This one is fresh off the Orion printer, which is currently down in need of a new heating resistor, but it printed a lot of these parts too. I had both of my printers busy for a couple of weeks. So this is the capstan that measures how much cord we've moved so far. How did I get this stuff out before? I don't know if I've actually done the cleanup on this. I mean, I've taken this part off, but I don't know if I've gotten the bolt holes cleared before, so that might be annoying. I think I'm using somewhat denser support material this time around than I was before. This kind of wants to come off in one piece, and it kind of doesn't. I don't know if it was just my imagination or the last one of these I did was easier. I got one of these at least partially cleaned up to test fit it, and at least took this part of the support off. It was not the easiest support to remove, but it came off in a couple of big pieces. So using a different tool maybe, like a little screwdriver, maybe a spudger. I really don't want the cord rubbing against all this stuff, but was I just using one of these? Oh, maybe this actually works all right. That was better. That almost cut my finger. Great. Yeah, I'm not quite sure what kind of CAD tool to try next. I've certainly gotten plenty of frustration out of Fusion 360 so far. I like Rhino, but it's not like a parametric CAD tool the same way Fusion 360 or SolidWorks would be. I don't really see any reason to go back to SolidWorks. I don't know, it's nice, but it's like hard to teach with because it's so expensive. And like I don't have a license for it, and getting one sounds super expensive. I mean, if SolidWorks had the same kind of like free for artists and educators and whatever that Fusion does, that would be pretty awesome. But I don't know if they can afford to do that. Then again, maybe they can't afford not to. How did I clear these before? I don't know if this is even supposed to have support material, but I don't think I could print it without like this specific support at least not with Cura. Oh, this doesn't go that deep though. This is just around the screw hole, and yeah, I think digging it out with the pliers works. Yeah, if SolidWorks had the kind of free-ish version that Autodesk has right now, I would be using them in a heartbeat. Like, I wouldn't have even considered Autodesk if SolidWorks had that. That's right, all of this is at a weird angle. But as long as I jam the pliers in there, the plastic seems to break down and come out. Oh, this is definitely a case where it would be nice to have a different tool though. Maybe a little flat-bladed screwdriver. I have way too many like tiny Torx screwdrivers that came in these kits with a bunch of other tiny screwdrivers, and they turned out to be really low quality, and so the ones I actually use are breaking down, and then the ones that I don't use much just hang out in my shop. I think this is what I want. Clearing out the hole that this nut goes in is not great. It might be clear enough. I'm going to try putting a nut in there. Maybe it isn't quite. Getting the nut out when it's almost all the way in is also not great, but there it goes. Oh yeah, this is a little better. Just scraping the top and bottom walls of the hole with this little screwdriver. And that seems to actually take off the material that I need to get out. There's a similar kind of support situation with the wall mount but like on a much larger scale. There we go. I think that was the last bit that I needed to actually get out. Langlebe asks why I prefer SolidWorks. I don't necessarily. It's just something that I would certainly want to try. I mean, I've used SolidWorks a little bit in the past. I don't have a ton of experience with it, but I felt mostly positive about using it, and it's less of a wanting to try SolidWorks and more of a wanting to run screaming away from Autodesk's cloud monopoly. And SolidWorks seems like a good place to go to get away from that. There we go, that's the screwdriver. Okay, so we've got a nut. We can see the nut lined up in there. Can we put this in? Does this screw have too big a head on it? No, I think that's fine. Actually, I think I designed this to work with these screws. Yeah, it's a better fit for that screw. This project is still prototypey enough that I don't really have like an overall bill of materials for it. I mostly just designed it with stuff that I had handy. And so there might be some opportunity to, like, oh, why did you use 3 different kinds of M3x10 screws? I don't think it's quite that bad, but there are a couple of places where maybe I could optimize to use more similar components than I did. I tried to do a bunch of that, but there's still more room for it. Okay, well that feels like it's threaded in there nicely. Let's back that off a little more. I'm trying to look in there and remind myself where it actually starts engaging with the shaft. About that far. Is this clean enough? I think I've taken off all the major burrs there. Alright, so that goes over here. Yeah, the cow aerodynamic image is pretty great. Oh, is that still not backed out enough? I think it's not quite angled right. Okay. Alright, what's going on here? I might just need to back out that screw a lot more than I had. Okay. Ah, and some more pressure. Cool. Then, not quite all the way down. It's easier said than done. That's running much straighter than the old one. It looks like it needs to move that direction just a little bit. Spudger. Oh, that looks better. The movement was subtle enough I was barely noticing it, but what I'm doing is trying to line this up with this pulley. And I think that's good. I'm just going to make sure this doesn't move as I tighten this next screw. All right. Much better than the previous print. The last one was super wobbly. Okay, and that's going to be on there pretty tight now. Okay, making progress. And this cord can get shoved down. Can give that a little bit of slack up here. Okay. So, is there anything else I need to thread lock over here? I don't remember whether I already put some on. No, I think everything's good. Okay. So, that's the top. So, I don't know. So this one's already thread locked. These two, I don't know if it'll, I mean, I might as well. It won't actually make it harder to disassemble because even if these nuts and shafts are attached to each other, then they'll just pull out of the nuts on the other side, so I might as well do this. This won't be that strong anyway if I'm just putting it on top like this. The way you actually put this on is on the threads, but this will give me just a little bit of resistance to backing out. Okay. So I think the next step is really just to get some screws ready for the two halves to bolt onto this. I might need to ask the CAD model what screw I'm supposed to use for that. Mouse is under everything. Okay. Okay, 8mm, so those are M3x8 socket head screws. Which is same thing I just used in the Encoder capstan. Alright. Let's start off by just putting 1/2 on there without the switch in tow. Okay, so I've got these loaded up in there, ball driver ready to go. It's a little easier to do this side first since this is where the wires kind of need to route. And then all of the, it'll be easier to put these in after this is in place, actually. Yeah. I don't have nuts on the other side yet, so that'll be the next thing to do. But I think right now I can just let this, like there's a little bit of over extrusion in the holes from the support material, and that'll actually hold the screws in until I add the nuts. Hey, James. Oh, and hello, Hedgeberg in YouTube chat. Oh, and Hedgeberg's also adding that there's probably not anything about in the Twitch terms of service preventing that. So, yeah, it might just be a random network problem on my end. Sorry for the lack of a Twitch stream today. I'll have to figure out what's wrong with that. I don't really have a good way of debugging problems that occur after I start streaming. I've kind of either got to go with it or stop streaming. Okay, well let's save that side. Let's try to put the nuts on next. I'm glad I put this down over the pile of glue, because otherwise it would definitely be all over my hands now. Yeah, and the ball driver makes short work of this. So the nuts are actually... Oh. Really? I was gonna say the nuts are hard to reach, but then I'm like, wait, can I even get to that left one? But I think it's just behind a pile of grease, which is fine. But it would have been nice to glue these nuts in beforehand. On the next winch I assemble, I will definitely do it that way. Oh man. Is there even room for the nut in there? That is a super tight fit. I must have been assuming I'd put these on beforehand. That's frustrating. Oh, there's Tuco. You see him? This is ridiculous. This is a terrible way to insert the nut. Oh man, yeah, I'm probably gonna have to take the frame apart. Damn. It's not that bad, but I mean, I just put some Loctite on some of the bolts that I don't have to get off, but I have to interact with. So messing with those bolts while the Loctite is drying is not really what I want to be doing. Let me see if I can get this under there though. I might be able to just flex the frame really slightly and get it in. Oh, man. I didn't already put a nut in there, did I? That would be embarrassing. I mean, it would be the right thing, but then it'd make it embarrassing that I'm worrying about this. I don't think there's a nut in there. I'm pretty sure I was like, I can just put the nuts in later. Yeah, I don't see any nuts. think I've got to take this apart. Okay, let's bite the bullet. I'm learning all these things about assembly order. Okay, well, this Loctite. This Loctite, great. I'm just gonna dig in. Oh, actually, I had just printed another SD card holder. I could use one. To keep the cards that need to be imported handy. I was talking about like fixing bad block, or like finding bad blocks on SD cards recently on Twitter, because I was having problems with some of my video footage getting corrupted, and I was trying to track down where that was happening. And I'm pretty sure that it was just one of my SD cards was bad, which I think I've taken out of rotation. This one says it's full because it's still full of files from doing my last bad block test. Anyway, somebody on Twitter suggested that I just buy, that like storage is cheap, you can just buy new SD cards and use them once. I'm like, well, I go through a few of these a week if that's the case. That gets expensive. Yeah, I think this person was not used to how big video is. Okay, well. Oh, this is, okay, so this nut that's covered in thread locker is coming out, which is going to be a mess, but we can deal with it. Let's take this nut out. Oh yeah, Trial says, I lost an hour assembling my Prusa having to backtrack to get a nut in. Yeah, this must be a familiar experience for anybody who does a lot of assembling things. I'll put these thread locker soaked nuts somewhere. And then I can just grab these like you're not supposed to and back them out. You're really not supposed to just grab the threads like this with pliers, but I don't have the right tool for doing this at the moment. And it's fine. Now it's got this slurry of thread locker, a little bit of metal dust, and a larger amount of plastic dust. Okay, that one's loose. Also put it in my pile of thread locker mess. Okay, so we're definitely doing the dip the nuts in E6000 trick again, because that seemed to do a nice job, and I think I'm getting the hang of it. Yeah, both of these have nuts on the opposite side. They just kind of want to fall as soon as they can. That's fine. All right, now this is annoying. So let's turn the whole thing over. And then you can take the top off. Pull some of the wiring through. Put that over here. And take that out. I've got to take the spool out next, which is annoying. If I take the spool out, I might take all this cord out because the cord is kind of annoying. I should have unwound this back when I still had it wired up. Okay, so getting this out mostly just involves this maneuver where I have to kind of gently unmesh the gears. Yeah, like that. That's easy. And covered in lube, so I'm not gonna touch it. But yeah, maybe I'll actually just wind this up the rest of the way. That might be easier than dealing with all the unwound cord. And I can thread that when I'm ready. Okay, so set this aside. All right, those are where the nuts need to go. Wow, you really get a tour of a lot of this mechanism today based on how much I'm having to backtrack. Oh yeah, Jess says looks like a giant Lego fire engine reel. That's a great way to think about it. Maybe I'll trust the autofocus now. See if that isn't it. Oh, hey Tuco. Oh, Tuco. Can I get the camera? No? Are you gonna move before I get the camera on you? Tuco was sitting on the socket set and it was super cute. If this robot was done, one of you could have aimed it at Tuco and it would have been awesome. But that's okay. For later. Alright. I need M3s, which are over here. I think I always end up having to open the E6000 with pliers because it always glues its lid shut. Boogers. Okay. Let's get a better camera angle. Yeah, and it is disappointing how bad those contacts were. Like, it seems like a good design. It must just be bad material choice. Tuco is nomming on some bungee cords. It's currently his favorite thing to chew on. To do, you know, because cats like chewing, right? Chewing's great. So there's some furniture he chews on sometimes, which I try to discourage, but I've also kind of given up on stopping him. But then there's a bungee cord that holds some chairs down at the other side of the shop, and it's under very little tension, and it doesn't seem to do him any harm to chew on it, so I've been letting him just go to town on that. Got it. Yeah, this is the way to do captive nuts. I mean, we'll use some of those heat set inserts actually, and those are nice for stuff that doesn't have to be super strong, but you know, they're fine for holding in circuit boards, but I haven't found a way to install them where they're really that sturdy in PLA, so depending on what kind of forces you're trying to anchor against, they might not be the most useful thing, but a hole for a nut like this that's glued in can do pretty much anything. I think I'm going to glue in the nuts for the frame also. Basically anywhere I can glue in the nut, I probably should. And I mean, if you're worrying about the nut kind of gluing in at just the wrong angle, and then there being weird forces on it when it's actually tightened, that's partly why I'm using a soft glue like this. This kind of has the consistency of hot glue when it's dried. So you can still kind of tug on it a little bit, and it doesn't, you know, it's not going to just crack loose. It'll actually kind of conform to the joint as it flexes, or conform to the underlying materials, rather. But yeah, it's also just kind of nasty stuff. Like, you definitely want to use ventilation if you're doing stuff with a lot of this. I did an art project a little while ago where I found it made a pretty cool effect when you mixed broken glass with this glue. And so I would coat the inside of this acrylic sphere with this mixture of E6000 and broken glass. I thought it had a really cool texture. I've still got enough materials that I should probably make some more of that. I just ended up making this art thing that I kind of burned myself out on, so I'll need to find a way to not burn myself out on it if I do that again. What you doing, Tuco? Okay. Anything else I can glue while I'm doing this? Maybe the shell nuts I was just talking about? 'Cause those are already close by. Hey, Tuco. Tuco's on the desk now. Those go in these little holes. Oh, that's pretty nice, actually. The fit? I hadn't actually tested this, but there we go. The side panels will just attach with these fairly subtle little panhead M3 fasteners that are totally out of focus now, but yeah. So in fact, the safe thing to do there might just be to put the bolt in to make sure the nut is held into just the right place, and then to put a little dab of glue on there. And in this case, I think I can just put the glue, well, I don't know. Yeah, that's probably fine. I was thinking about maybe wanting it to be kind of underneath the nut too, but, you know, again, the glue here is completely not load-bearing. It's just to keep the nut from falling out. Oh, that one needs to be pushed in a little further. Yeah. Oh no, Whisperfist says, I put up 4 walls of a house once and had to backtrack, lift up each section of the frame to put on the forgotten metal tie plates on the bottom section. Oh no, that sounds like a big letdown. Yeah, there's always an opportunity to go a couple steps forward and a couple steps back. Okay, well, so 2 of these on this side. Let's do 2 more on this side. It's nice that we can still hang out while I'm doing stuff that I feel like I'm not actually that good at, like this mechanical stuff. I basically got into making, well, I mean, like, I've always enjoyed, like, making electronic things, and usually that would involve some kind of mechanical component, but I really couldn't do that much until I started thinking about it in terms of 3D printing, because I didn't really have the like the full set of tools that I would have needed to, like, I mean, you know, I would make things with like a hand drill and like balsa wood and hacksaw and stuff like that, but that's a little different than thinking about all the little details that you need when like machining or 3D printing. So it's been kind of a neat thing to experiment with. And it does remind me a lot of, you know, other kinds of design that I'm more familiar with, like software and hardware. Just the way that it's kind of this language of constraints that you've got to learn to speak in. And then specifically, it's been interesting just getting to know the strengths and weaknesses of this particular medium of 3D printing. And it kind of ends up with designs sometimes that might look a little bit weird to people that are more used to machining or injection molding. But I like finding the way to speak in a new medium and what that sounds like. I think it's interesting. All right, let's add a little glue here while we're at the gluing. I'm just gonna squirt a little dab behind the nut on each one of these. All right. Let's put this on before it gets all over my entire desk and glues everything to everything else. So I think these are probably set up enough that we can start putting the frame back together. Let's just put the spool in. Cool. That's actually not a bad maneuver. I mean, the basic way that works is to squish the gears as hard as you need to get the other bearing to fit into its little housing. That works out all right. Hey, Tuco, are you sure you want to be right there? All right, lined up again. Oh, and let's put the spool, or this roller in. Now this again. Back to the part of this where I need to care about 13mm versus 12mm nuts. Alright, so 13mm nut goes in this side. I've got a 13mm socket, and so it's like, okay, I need one that doesn't fit in the socket, and then I'll hold that one on the back. And then I need one that does fit in the socket, and I'll hold that with the socket. Oh, Tuco wants to go outside now. Hey, Tuco, maybe in a sec. He's super good at asking for things when I have my hands full, but it's okay. I totally don't have the nut. Let's try this again. Yeah, this part is a little annoying. I think there's a tool, like a shaft driver, I think it's called, which is actually what I want for this. Can't quite tell if it's engaging with the threads on the nut. Okay, it is. Cool. Oh, you know, I think with the 100mm bolts, I think what happened is I was trying to get M8 by 100, and instead I got like 100 M8 by 10s or something like that. It's like, oh, that's not what I wanted. But that was one of those things where I was like shopping for cheap parts from a variety of eBay sellers and trying a couple just in case one of them was super slow for some stuff that I just needed to have around in the shop, like threaded rods. There's some red plastic debris. That's fine. Okay, so back to the thread locker. Okay, one side back on. Similar deal on this side. There's a long shaft, goes in here. And big ol' nut. Gotta be careful how I put it down because I want to sit it down directly on top of the load cell. Now it's acting like it's cross-threaded. So I backed it out and I'm backing it back, or turning it back in. I think it's... Yeah, I think it's engaging now. Let's double check. Yeah, it looks fine. Let's tighten it a little more. That one's a little bit blind because I can't tell how far into the other nut it is. I can just tell how much of this we've got left. But that looks good. Oh, nice. Exposed aluminum. Well, that's yeah, unintentional conductivity, I guess, is certainly a hazard when working on wireless circuits and debugging them. Okay, so it'd be really easy to leave out this roller, but I didn't. The roller's there. This is all in. Those nuts are in. All right. In fact, I could even thread this through. I'm not gonna worry about that though. Let's attach these bottom pieces. So same deal, except now we have captive nuts, so I'll actually have something to tighten these pieces into for once. So I think I wanted to do this one first. Just like that. And do we have nut? I'm not getting... I think I pushed the nut upwards, which is not the end of the world, but slightly annoying. The glue is not really fully set at this point, so let me find something to push that up enough that I can make contact, and then I can tighten this bolt. I guess I could also use a longer screw, but shouldn't need to. I might need something curved to push that up there, though. Like bent tweezers, maybe? I don't know if I have a good tool for that. Well, maybe I'll try using the end of this Allen wrench. I'm just trying to put some pressure on the back side of the nut. What is going on here? Are we just like subtly misaligned or something? The screw is definitely in the screw hole. I'm pretty sure I checked the CAD and this is supposed to be an M3x8, which is what this container is labeled. Let's see. I can see the nut threads in that hole and they're lined up. They're just pretty far down. Oh, I'm getting hair in the gears. That's never a good thing. That's a nice thing the shell will hopefully avoid, is hair in the gears. Let's just try using a longer screw to pull the nut forward. That might be the easiest thing to do. If I can get a longer screw in there. Quite tell if that's working. Oh yeah, it is. Okay. I was like, I looked down and it's like about to dig into the gear. No, that's gone. Let's just pull it up now. I don't know. This is acting like maybe this is supposed to be a longer screw, but I don't think it is. I'm going to assume that these screws are supposed to be longer. That's just weird because this doesn't match what I was expecting for my CAD model. That's fine though. I could debug why that's happening, but I don't necessarily care that much right now. So those are M3 by 8s. Were they not supposed to be M3 by 10s? I think I have some M3 by 10s. I have a bunch of M3 by 16s, but that might be too long. What are these? Hey, Tuco. Yeah, these are 12. These might be too long, though. Let's just try it really quick. That is sticking out a little bit. Well, I can tighten this maybe and bring the nut in closer. Is that a thing I can do? Ooh, is that working? Because it might just be the nut sitting on some 3D printing imperfections instead of where it's actually supposed to sit. So now that I've tightened that and backed it off, let me see if I can put an M3 by 8 in that spot. That motor has a big magnet in it. Imagine that. No, that's still too short. How is this not an M3 by 10 location? Or an M3 by 8, sorry. It looks like it is M3 by 10. Do I only have 12 and 8? I think 12s will work. It's just a little long in the middle. Like it almost touches the gear below, but not quite. Like over here, it's fine. There's plenty of extra room here. No, that one's not coming out. Well, I'm going to try tightening an M3 by 12 in the middle, and I'm going to see if it actually has room. That nut is not anywhere near where it's supposed to be. Okay. Now I'm failing to tighten it, like the nut is just spinning around in there. Oh, maybe not. It's hard to tell. Maybe there is just... Maybe it is my theory about 3D printer trash being in the way. It feels like it's getting a little tighter, but it's hard to tell whether it's just spinning or not. Oh, maybe it is. Okay, Oh, you can't quite see what's going on in here. That's the end of the nut or the bolt that I've been tightening. It is not great, but it is acting like that nut is just not holding its position well, and also not sinking all the way to the bottom of the hole it's supposed to be in. Yeah, okay, I can get the nut entirely out, it turns out. Well, there's the nut. Let's just try a different nut. Clearly the glue didn't do its job right there. Let me try this with an M3x8. I might have to put this in upside down so gravity's on my side. This really should work with an M3x8. I can see where the end of the bolt is, and it's a really good place for the end of the bolt to be. This is definitely supposed to be an M3x8. I think something was just going wrong with the nut last time and it wasn't threading correctly. There we go. That's working. Yeah, and now the problem is I think just that the hexagon is actually too big and the nut is spinning in it, which is unfortunate. That might be I just added too much margin and got myself in trouble. But I think if I can wedge something in there to keep the nut from spinning, like one of these toothpicks, will be fine. Yeah, it might be that it was working before, it just didn't seem like it was because it didn't actually tighten all the way down. I can't quite tell if I've managed to keep the nut from moving. Other strategy is to stick some epoxy in there. I'm gonna focus on the other 2 screws for a sec. So that one is threading, it's just not tight yet. And I've got a longer screw in top, which is fine because it's got plenty of room. It's just that middle and the bottom are a little tighter. The top one also, I'm feeling the nut biting in just fine, so it's a little weird. Let's put in another M8 gently. Or M3x8. M8 is a different kind of thing. Oh, that feels better. That feels like it's not grabbing. Can't quite tell what's going on in there. Try a toothpick. So I'm just trying to tighten these bolts where the nuts are not really cooperating and there's a bunch of stuff in the way. The top one is the only one that's working really well right now. I mean, they're holding, they're just not tightening down the way I expect them to. Well, I think I can go ahead and try adding the other side though. I think I'm going to cut the wires from the motor to the motor driver and put them back later, because they're getting in the way right now. Yeah, like that. So let's put the 2 halves together next. This has also got some nuts in very deep holes. I'm going to try using another bolt to stuff the nut all the way down. So I've just got the nut just like barely on the end of this other bolt. And then I'm going to use that to get this one engaged, if I can. What is keeping that? Feels like it's close. Maybe the nut just wasn't pressed down all the way. This is always more tense, like the first time you assemble something, like bringing up a new circuit board. I can see the nut, the end of the bolt spinning in the spot where the inside of the nut goes. It looks like it should be catching, but it doesn't. I think the nut might just be in there a little crooked. I'm gonna try picking up the nut with this other screw to check it out. Yeah, that's fine. And I still see the end of that in there. Why is that so hard? I'm just trying to get it out. Yeah, that seems fine. The nut side on its own is working. If I try to do the same trick where I just kind of pull the nut all the way back, maybe, and then let that screw out. Oh, I might have it now. Let's try that. I'm trying to be careful about the wires over on the other side here. Oh, the ribbon cable. This ribbon cable needs some attention. Sorry, some of this is off camera. Trying to get the ribbon cable and this round encoder cable to lay in the channel that is supposed to be how to get out of this little constriction. There we go. Ah, is that it? Is it? Why is this so bad? I think this just should have been designed so that more of the screw passes through the nut before it stops. It just feels like there isn't quite enough of this sticking out for the nut to grab onto, which seems like it shouldn't be the case. I don't know why that's the case. I think this nut just keeps tumbling around inside where it's supposed to be hanging out. the nut is totally not sitting the way it's supposed to. I can see through the center of the nut, but something about the way it's sitting is preventing me from actually getting a thread started. It's like it's sitting at an angle. And I'm trying to push it either flat or to try to like flip it out somehow. Okay, well that flattened the nut. And then now I think it's back at the bottom. Now if I turn this, yeah, there we go. So that's threaded. It's possible. Like what I really want is a little cylinder that I can push that is maybe 4 millimeters in diameter. I don't know if I have a tool that's just right. Ow, what just happened there? Sorry, this isn't haptic YouTube. I mean, it's possible I just made a terrible mistake in CAD and this isn't big enough, but like I can see the screw on the other end and it looks like it's in the right spot. How is that even happening? I think the screwdriver is going inside the nut there, which is not helpful. Yeah, I have a slightly wider screwdriver. Oh, this tool maybe? Why doesn't this work? These are M3 by 35. Is it possible I designed this for an even bigger M3 screw? I'm pretty sure I didn't, but... like, that sticks out fairly far, right? And how deeply does the nut actually want to sit here? Pretty deep. The nut is pretty far in there. Oh, maybe it's at kind of a weird angle though. Maybe that's the issue. Let me see if I can use this to pull the nut out. Can't quite tell if this is working at all. That's not quite what I was expecting. Oh, thanks, camera. Yeah. Well, that's definitely not how the nut is meant to be used. Okay, let's try that again. Maybe one of these slightly longer screws. That was like about there. Okay, I'm gonna try just pushing the nut in with the front of this tool. Can I magnetize this tool? No. Oh, yes, I can. Slightly magnetized. Oh, Tuco put a plastic nut in my socket set box. Is this it? Oh, that feels promising. Okay, maybe this is just the pickiest screw joint, but okay, now that it's together, I'm just having that problem with my ball driver being a little too small. Great. Okay, that was frustrating, but I'm glad it worked. Because that, I mean, I checked over that part of the CAD model a few times, and that seemed like it should work. So, let's make sure the screw, or make sure the button up here is in good shape, and then put those screws in. Wonderful switch up here. I'm gonna leave those loose until after we put these in. So, can we use the same trick? Magnetized wrench, nut on the end. Let's maybe just clear this hole out a little first. I think it's just one of those things where there were probably some 3D print inaccuracies that were causing just them not quite to line up, or to meet, rather. And then once I could get them to meet, then the clamping force from the bolts takes care of everything else. And powers through any more 3D printing boogers left over. this screw head is really inconveniently sized. This is a 2.5mm ball driver, but it's acting like it's just a little bit too big. Or the screw's a little bigger than the driver, rather. Now I've got to get these to line up despite maybe a tiny bit of warping. Retrojunk asks, can't I use a little longer screw? I mean, no, I can't. I don't have a little longer screw. I have a pretty decent stock of M3x35s. I think I have some M3x40s, but those would be too long. I mean, for here they might work. I don't think I have enough M3x40s to use them everywhere that I'd have that problem, though. Anyway, I could have designed this to leave a little bit more extra screw length, but I wanted to use most of the screw length for actually reinforcing the plastic, and I don't need, like, the screw that's sticking out past the end of the nut is wasted, so I didn't really plan to have much of that. And I mean, if you're asking, well, could I have used a screw that's just long enough such that I didn't need to bury the nut as much? Well, then I just need a bigger assortment of really long screws for this project, and I kind of standardized on M3x35 since I had so many of those handy. Anyway, I think this is working fine. I just needed to come up with the right technique for putting these together. This would be nicer if this socket or this wrench was the right size, though. This magnetic holding for the nut kind of works, but that is really close. What is wrong with that? It's like I can see the end of the screw and the end of the nut and everything looks fine. maybe that's in there. Maybe I just need to tighten it. No? No. Can I push from the other side with a long screw, maybe? Whoa, are these M3? I have some really long countersunk M3s. Not very many, but enough to do this. Maybe this is a bad nut. I don't know. Try a different nut, in case that one's kind of scratched up on the inside. Yeah, that's super annoying. It really seems... Well, part of the problem is that I think that this case is not quite closing all the way, so what is that getting stuck on? I don't know if it's stuck on anything. I think it just needs some clamping force. Which is exactly what this screw is for. Well... Oh! I think there's a support material in there. Ha! I bet that would explain it. Yeah. That was just acting as like a little shroud that exactly covered the nut. Okay, just need to clean that out a little better next time. That'll save me some annoyance. Yeah, okay. That's much better. This end is not a ball driver, and so it fits a little better, even though it's not ideal. Alright, that'll be fine. Great. Just test this e-stop switch while I have it out. Not that I expect it to be amazing, but let's at least see if it's a switch. Thanks, switch. Yeah, this is fine. As fine as I currently expect it to be. Okay. So those screws are tight. I think I was gonna still go back and tighten this screw if it isn't. Now it's tight, okay. Now, a few more of these M3x8s for the motor, or around the motor. These are, I hope, some of the more annoying screws in the whole project. Oh, I might need to push that nut down, but that one's mostly in. I'm gonna get these all mostly in and then go back and try to tighten them all as best I can. These should all be M3x8. Okay, so none of those are really engaging with the nuts, especially right now, but that's the next job. This kind of doesn't have any clamping force down to this side right now. It's flopping around a lot. I mean, there are a couple places I could use longer screws on this side if I needed to get some early clamping. Maybe. I mean, this is, oh, okay. That's a danger then. So some of the E6000 glue on these nuts has cured into a position where the nuts aren't fully at the bottom. And so it's flexible enough that I can get around that by putting the nuts in, but it's not really the most helpful thing for the glue to be doing. Maybe I will use a longer nut, or a longer bolt right here, because I can get away with it, and it would help to have the length at the moment. pliers are not quite long enough. Replace that with, is this 12? Yeah. There we go, that's engaging. There we go, now it's starting to actually tighten. That's what we want. Next. Yeah, there we go. Starting to pull the nut, but strip out the hexagon that it's sitting in. It's not what I want. Yeah, that's frustrating. I guess I should have made the hexagons a little smaller. I don't think I made them much bigger than the actual nut this time, but this might have been another case where maybe my actual nuts are a little smaller than the CAD model of a nut that I was using, and I should have double-checked that. Can't tell whether there's just stuff gumming up the threads or whether it's cross-threaded. It's like it only wants to grab on when it's cross-threaded. Slightly longer screw would help here, but I don't know that I have a slightly longer screw. It's acting like it's just plain old cross-threaded. Like I get nothing, and then all of a sudden it just wants to rotate the entire nut instead of tightening onto the nut. And so I'm trying to back it out and then adjust the angle and then go again. So far, no luck. Oh, this nut is not happy. I think I want to back it off so that it's not cross-threaded. Make sure that they're really totally backed off, and then just like push it in there. This is not easy though. I'll try to find a better pair of pliers for this. Maybe one of these. Trying not to have a negative effect on these gears. Oh, maybe I should just take this nut entirely out. Okay, it feels like there's a burr or something on the threads, or I just got glue in completely the wrong place. And luckily, I can still get this nut out without taking the whole thing apart. It's nice that these gears are flexible. If the gears were not flexible, I probably wouldn't be able to get this nut out. Plenty of this delicious Teflon schmoo everywhere. Okay. I'm just going to unplug everything from the circuit board. I think I'm going to need that anyway for the wire routing, and that will help this be less of a mess. Alright, that's totally unplugged, and now I can get these wires out of the way. Alright. This way that these two brackets attach has got to be the worst part of this design so far. Isn't prototyping fun? You get to spend tons of time making something and then discover that it's still terrible. Okay. I think we can go is so close. I need like a little curved pick or something. Yeah, I'm actually terrible at motivational speaking. Excuse me. Oh, maybe these will help. So, curved tweezers. Kind of big. Okay, well, I'm having trouble with the nut spinning again. I don't think it's cross-threaded this time, so I think I'm gonna just try to jam something into the hexagon around the nut and then tighten it. I mean, I think this thing will be good once it's assembled. It's just not as easy to assemble as I would have hoped. And those are the kinds of things that you figure out during the first prototype, I guess. That is really not happy. I don't know what's up with that nut. Could be that it just needs more holding down before I can actually tighten it. Could be still a little bit cross-threaded. I don't really know. What about this one? The process is the product. Yeah, that's kind of what I'm trying to do with this streaming, I guess. I'm always a little unsure how well that works when I get into these complicated projects. But then with this, because like with this project, I am certainly interested in the process as probably the primary thing behind it, but more than, like, I do actually want this cat camera, like, and I've been trying to just keep working on getting that going so that we can actually use it. Oh, these nuts are just not happy, and I can't even really get to this last one for tightening it. I thought the little hexagonal hangouts would be enough, but clearly not really. I don't really have enough room for a longer screw here, but I'm going to try adding one just in case that helps. I don't think that's even the problem, though. And I was also concerned about, like, I don't even know... Some of these bolt holes, a longer screw wouldn't necessarily have room to get in there. Let's try this. There's kind of room for that. Yeah, I guess K-Temkin does point out that there's a lot of experience to be gained. And, I mean, that's kind of what I'm used to being, you know, like when I'm doing something, I usually have some end goal that I have in mind while I'm doing it. But then the thing that I'm used to actually tending to be really, you know, durable after the fact is really the experience more than the product. This screw is too long, but it successfully managed to pull the nut into position, I guess. So let's put the shorter screw in here now. Yeah, and it's been a great learning experience, like all the stuff, the more mechanical stuff that I've been trying to do since getting into 3D printing a bunch of years ago. Because really, I mean, I used to build things all the time, but the structure of those things was usually limited to, like, you buy a project box and cut some holes in it, or cutting things out of wood with a hacksaw, and making, you know, and I would do things that were actually a little bit complicated. Like, I made this thing a while ago that was a USB interface for some PlayStation controllers. And so I actually, I got some, like, PlayStation controller extensions, or like a multi-tap, or some other, like, consumer electronics thing that had the socket that I wanted for the PlayStation controllers, and then cut that out with the Dremel, then cut some matching kind of oversized holes. Oh, this is finally working. That screw is good. Okay, having a good screw on either side of that joint makes me much happier. Yeah, so I cut these matching holes for these kind of PlayStation controller modules that I pulled out of some consumer thing in a project box, and then used epoxy and paint and a lot of sanding to kind of smooth out the interface between the two, and managed to make something that looked pretty good in the end. But just so much work. Much easier to do CAD and 3D print it, and you can end up with a nicer looking result a lot of the time. Can I do anything with that middle screw? Because I've got some good screws on either side. The middle is still not holding. But it is really tempting to just put a drop of 5-minute epoxy on the back of that nut to hold the nut in place. I just can't tell if it's cross-threaded or not. If it is cross-threaded, I should back it out and fix it. I mean, even if it isn't cross-threaded, I probably have already stripped out my hexagon enough that I can't rely on that to hold. But like, if I can get the nut tight enough, then it'll hold itself and I don't need the hexagon to hold it. So I'm going to try doing the same thing that I was just successful with on the right side, and use a longer screw to pull the nut into place, and then put the shorter screw back in. Even getting these screws out is kind of annoying. Gotta grab the screw head with the pliers and yank, I think. Can I even get that screw head out? Oh, that's coming. You might also notice the motor wobbles just or like can wobble just a little bit. I was intentionally leaving the area around the motor a little bit free because it does tend to move around just a little bit. Like the plastic around the motor mount kind of takes up some of the misalignment between the motor and the gear or something, such that, like, every time the motor, I guess I don't know whether I guess it must be correlated with the rotation of the input gear, not the spool, but as that rotates, the motor can flex by maybe like 0.5 millimeter. Or it flexes in its mount, rather. Oh. backing out the driver. I'm having second thoughts about trying to get a longer screw in here now. Well, got this one out at least. Okay, let's temporarily try to get this much longer screw in there. I think I saw a question in chat about pull-ups on SPI, and usually SPI doesn't rely on any pull-ups or pull-downs. If you might be getting into a state where your peripheral is powered up and your SPI master is not, then a pull-up on chip select can be good. Yeah. Okay. So maybe part of the problem is when I'm driving this screw in, it kind of by necessity has a little bit of a weird angle because of how I'm putting it in. And yeah, I mean, it's a little easier with the shorter screw because I can get the angle mostly set and then use the ball driver to drive it at an angle. So here, I'm mostly just trying to manipulate the screw so that it's actually grabbing onto the nut instead of just pushing it aside. I'm getting bits of metal dust in my gear, which is probably not great. And I lost my nut. Yeah, I don't think this strategy is going to work because this nut, or this bolt, is just so long that the process of getting it out, I think, is going to disturb where my nut ends up falling. So let's go back to plan A.5, take this out, but put the shorter screw back in and just try to guide the nut into the right place as I tighten the screw. And so maybe the thing that's getting it cross-threaded is actually this kind of tilting action that I need to put the screw in. So maybe let's put the screw in and then put the nut in this time around. Alright, got a fresh M3x8 screw. And that's mostly put in. Oh, did I not replace this one on the right with a shorter screw? Because that's definitely got a too long screw in there right now. Okay. That'd be a good way to lock the spool into place. Some of you may be thinking, oh, this is going to suck if you have to do this to every spool. And guess what? I'm thinking the same thing. But I don't think it's going to be this bad for every spool. I think I'm going to find nicer ways of doing this. Oh, okay. I think I got that one in. The one on the right is still grabbing the nut. Thank goodness. And now it's using an actually M3x8 screw instead of something enormous. Now the screw on the middle is lined up, but missing its nut. So let's try that next. That nut has some garbage in it. Is that the actual nut that I just... No, here's the new nut. Yeah, watch out for nuts that are full of plastic shrapnel. That's also probably part of the problem. This is moving around like there's some springy, partially cured E6000 in there, which I'm sure is part of the problem. So now I'm carefully pushing the nut down. It's acting like it's all the way down. This is kind of acting like there's some junk in the hole. Like it would actually help to maybe use a longer screw. There just isn't really room for it on the other side. Kind of scrape at the hole first, maybe? I'm trying to take the nut back out. Okay, I'm just going to try to feel for some debris in that hole. With a smaller tool, maybe? I really could use something more curved. These tweezers. I don't feel anything obviously terrible in that hole. Oh man, I still can't get over how much resistance there is in that e-stop switch. I'm glad I'm only going to be using it for like a logic signal. Well, logic signal or 24 volt logic power, which is also pretty low current. Why? Why? Acting like the nut is just not seated all the way in there, but I don't know why that would be the case. So I'm wondering if maybe it's possible the end of the screw is just angled very slightly relative to the center of the nut. Which is also something that'd be easier to diagnose if I had a little bit more extra screw length here. Well, is that Chuko or somebody outside? I think that was somebody outside. Okay, well, how hard is it to get a longer screw in here? Pretty annoying. Oh. It also just really does not look like this nut is sitting all the way down. Like it really doesn't. Maybe I can force that slightly differently. maybe something to do next time is, while I still have this frame disassembled, try just tightening these nuts completely down. And in fact, maybe even just glue them with some of the E6000 while they're tightened onto a dummy piece. That could solve this problem before it happens. I just can't get to any of the angles I need to get to in there. Okay, well, I've got one idea that doesn't involve taking this whole thing apart, which is still to use the longer screw to suck the nut down into position. Let's see if I can even get a longer screw in there. First step is to take this screw out. I wonder how the 3D printer is going. Oh, let's take that off the printer. I'm wondering whether I should start the frame. I'll have to see if I have any clear PLA handy. Or the shell, yeah. So, I don't have any clear PLA. It's quite possible I have some clear PLA waiting for me right now at the post office, but for now, I'm just printing another copy of this. Anyway. So. different pliers, maybe? Those pliers, much easier. Okay. Can I put it in with pliers too? Get it started at least. See, this might just have too much bending to get around the motor though. I'm kind of screwing it in past the part where the motor is thickest. If I can get past that, then I think we're free. Oh, bring us to the post office with you. Oh, that's a good idea. I wonder if I could... You know, I live actually super close to the post office. I wonder if the Wi-Fi from here would reach there. And then I could... Like, clearly I could do like a real road trip by streaming directly to the internet, but to integrate with this setup, I'd have to stream back here first. But I think I could do that. Okay, let's get another M3 bolt, or M3 nut rather. Let's make sure this M3 nut is actually good. I'll find that later, or my foot will. Okay. That just started rolling away. I guess the center of my desk is a little bit lower. Right. So I think this goes in with pliers. Like that. Kind of feeling for the head of the screw. Should have printed this part in clear so I could kind of see my tool. Okay, so that's threaded. I don't think I have room to actually tighten the screw to bring it all the way down because the screw is just so long. But now I can press the end of the screw. That still does not seem as deep as it should go though. Sorry, little gear. It really does not look like that nut is as deep as it should be in there. Which is frustrating. Maybe I can pull this end and then bolt. Nope. That's not really helping. Okay, well, can I back this bolt out without moving the nut significantly? it's possible I've gotten it pushed far enough. It just doesn't seem quite like it. This is like grinding against the side of the motor housing as I take it out. Okay, that's pretty much out. Pretty much being the operative word. There we go. So back to M3x8. Do I not have like an M3x10? That would be useful. I think the next size up I have is probably 12, which is too long. I think I just need a way of pressing down on the nut more. Like, I think there's just a little plastic booger or something that's keeping it from seating completely flat, and I just need to compress that just enough that I can get the nut to actually, or get the screw in the nut to grab. It's just a super weird angle to actually press down in there. Grab some of my other screw bins, because an M3x10 would be really handy right now. Oh. I have more M3x10s than I thought. That might be a good sign. M3x10s to the rescue. Okay. 3x10 this time. If I can get away with using M3x10s for all of these, that might be nice. Oh yeah, I think we got it. Okay, the nut is spinning again because of me stripping out the hexagon, but I don't think it's cross-threaded now. So I think now I can just jam something in the hexagon and then tighten the nut the rest of the way. Yeah, this is working. Okay. Definitely requires something to be jammed in the hexagon because the hexagon is thoroughly stripped, but okay. I think all 3 bolts on this side are tight. Let me just check them. Yep. Well, modulo the stripped hexagon, but yeah. Oh, I should probably try to tighten the middle one some more. Okay, that's fine. That's not going anywhere. Other side. How's the other side doing? It's so nice to be on the other side. I'm getting so tired of that side. Okay, so nothing. So the left nut had like no engagement. I'll have to figure out what's wrong with that. The middle one looks like it's fully on there. I think I just need to jam the hexagon on the middle one again. I definitely made these hexagons bigger than the nuts. That was a mistake. I'm finding it really hard to jam this middle nut. Oh, maybe it just needed some more tightening. I think the nut is still spinning. A little hard to tell. What about up here? That one's nice and tight. And the bottom one? The bottom one was nothing. Let's see if we can fix that. RetroJunk says a couple of washers might help. Yeah, on the nut side. I mean, if I had designed it to have room for that, then yeah, that'd be a good thing to include next time. Well, maybe. I mean, I think the washers would definitely be a help on places where I have a nut hole that's like backing up against support material or something where I can't make it super flat, but these should be pretty flat on the bottom. I don't know. I guess I don't know how a washer would help this specific one. Okay, I don't see anything wrong with the nut on this one, but it's not biting at all. I'm going to replace the screw with an M3x10. Ah, that's better. Hexagon is a little stripped, but I think it'll do. Okay, well that side has two screws that are holding reasonably well and one that's holding really nicely. And the other side, they're all holding really well. Let's check these sideways screws. See if they're still good. Yeah, I think so. Yeah, that's fine. Okay, well, I think that brings us to this point where we have the top frame, the bottom frame, and the measurement assembly all put together. So we can route the cord now just to get it kind of out of the way. Normally I wouldn't even have the cord on here until later in the process, but I had already been testing this winch and forgot to dethread it. So let's take off that much cord. So then that cord goes behind this roller, around these rollers, I'm going to cut this end just to make it a little easier to deal with. Using the dullest tool I have on the desk. So you have to kind of stick the cord through these two rollers, around the new capstan, under this pulley. There's a little bit of a tight fit when that's fraying. And that will finally go up to the ceiling. Okay, what's next? So mechanically, actually this might be a good time to test the wall mount bracket that we just printed. Oh, that's a good idea from Nicholas about the hex cavities for nuts having a kind of a conical draft. That's a really good idea. Okay, so here's the latest wall mount bracket, which is still covered in printer garbage. Let's clean this a little bit. Oh, nice. That just takes it off and leaves a big old chamfer behind. Yeah, easy to take a little too much. I think maybe multiple passes at a lighter pressure. I kind of sat next to a bunch of people who did mechanical engineering at this place I used to work, where we were kind of, it was kind of like it was on campus. This was while I was going to school. And I don't know, I had a pretty bad relationship with school, but this particular on-campus thing, which was like my job and not the classes, I actually kind of liked it. I was writing firmware and designing boards and stuff. And I never did any of the mechanical engineering, but it looked fun. And I think now that I've done a little bit of it, I think I think a lot of what seemed fancy was more like the tools and stuff rather than like really fancy procedures they were using. Because I can think back to a lot of the stuff they designed and it seemed similar to stuff that I'm familiar with now. The exotic stuff was more like thermal simulations and stuff like that. It's easy to have to maybe a little overdo it with the deburring tool. Just trying to take care of this corner, but couldn't quite get the right angle on it with that tool, so this knife maybe. Dylan's worried about my slicing. Yeah, I try to slice away from me, but sometimes I get carried away. It's tungsten carbide, it won't break. Yeah, sure. Usually, even when I am slicing toward me, I try to arrange it so that it'll hit something else before it hits something super important, but, you know. Okay, this is mostly done except for this giant area full of supports. This is like a U-shaped cavity in there, and it just wants to collect support material at the bottom. It means that you end up with like the last couple of layers of supports are almost tangent to the edge of the opening. Oh, metal spudger was good for this last time. Well, maybe the best tool is the one that's actually within reach. Actually, this might help. Oh, this is what I was looking for. Yeah, in my experience with PLA, it does not sand well. Much better to cut PLA. This is just kind of a deep hole. A lot of support in there. There we go. Spudger and pliers. Yeah, it gets a little hard to tell when you're even done here. Gotta actually get some light into it and watch for a curved edge instead of a bunch of flat edges. Okay, and then the goal is that one of these fits in there. And then, do I not have an M8 shaft just right within reach? I guess we could try it with this. So then the goal is you does that fit? There are some burrs that need to be worked off. That's basically it though. Let's tighten this. Yeah. All right. Let's not slice my thumb open. Okay. Well, that looks good then. So, and in fact, we can even attach this to an actual 2x4, because that's what this is designed for. So for that, oh yeah, this will be easier once this is actually attached to something larger. So, do that, loosen that, and then this piece can stay on the wall mount if you want. Whew, nice. So, let's see what kind of screws to use. This might be another one of those cases where I have some screws that are way too long and some screws that are way too short. I mean, worst case, I know that this works pretty well with 3-inch screws. They just stick out beyond the 2x4 a little bit, which is not ideal. These are what, 1 and something or other, 5/8. Yeah. And these are not long enough for the long spots, but they're long enough for the short ones. So I could put in a few of these. Nice big countersinks this time. Then the other option are these big ol' 3-inch screws. Here they are. So these will fit really nicely up here. Oh, there's a little bit of brim I forgot to remove. Yeah, I think the countersinks are the right angle. The problem I had last time was that they just weren't big enough diameter, so the screws didn't sit flush. But yeah, the countersinks are 90 degrees, which I think match these screws. I was fussing with this top edge a little bit more still. Alright, let's put this on some wood. Is this the right bit? Oh. Which of these Phillips head bits is even closest? Actually, these are all pretty weird. I think it's this one. Seem to have misplaced the little magnetic chuck for this drill again. Okay, so I think if I'm going to make like a stand for this, I might as well put it near one end of the 2x4 and then probably clamp the other end to something, or clamp both ends to something. Let's put it maybe there for now. Right around this knot, sure. What just happened? That screw went deeper than I expected it to go. All right. I did print this with not the most infill, but that is still surprising. I think I used my regular settings. Let's not use that much torque. Okay. Note to self, make sure to adjust your power drill before screwing into 3D printed plastic. More than that, though. seems like the right amount. So we are hitting through the back a little bit, which is not the best thing, but put some tape over that or something so it doesn't poke me. That sounded terrible. And this thing is super sharp on the end now. I'm going to try putting another piece of wood right behind this just so that it's not super sharp. Let's put that together with something less long. Why do I have such terrible sizes of these screws? Actually, I think if I put some 3-inch screws through here, that'll be fine. Prototyping. I really need my longer bit for this screwdriver. I'll of course find it as soon as I don't need it anymore. Okay, that's over. Oh, interesting. Andre says they're having some trouble with the video. Can you explain what kind of trouble? Is it just like not loading, or? Because I am not quite sure how to debug that, but I'm interested. Yeah, I'm using a lot of screws. I mean, the screws are where most of the strength comes from. That's what I'm relying on more than the plastic in this particular bracket. So, something like that. A little bit of wax on those screws, okay. Like candle wax or something. I assume you mean to lubricate them, but I just haven't heard of doing that. Oh, also maybe I was trying to melt all your faces off. Maybe that's the point of this whole stream. Okay. Trying to get this on camera is also its own special thing. Didn't I? Here it is. There's a little red biscuit goes up there. Actually, you know, maybe it's easier if this stays on there. So the red thing goes in there, then this kind of seats in there, and then you tighten the red thing. And then with it partially tightened, you can still set the angle, and it still holds pretty well. And then you can kind kind of crank it down as much as you care to. Yeah. That's more mounted than this thing has ever been. That's pretty great. Let's try to get more of that on frame. Well. Yeah, it's big enough it's hard to get on frame here. But yeah, well, that's pretty nice. I'm happy with the wall mount bracket so far. This feels pretty sturdy. And I mean, it's having no trouble holding its own weight, and it feels like it'll hold plenty of this kind of load too. Yeah, I mean, I wasn't super concerned with the noise. I figure everybody on the client side has a mute button for a good reason, but yeah, pilot holes are usually how I would have gotten rid of that. Anyway, this is clearly very temporary. I think the way I'm actually going to be attaching this is probably not too different from this, but I'll probably cut the wood to a nicer length and then use clamps on either side, and then I might build little frames to attach these to wherever they need to go. It just seemed like this piece of plastic was probably a good way to kind of make the joint between kind of all of this like engineered 3D printed stuff and just like bulk hunks of wood. And I think I'm pretty happy with that, because this is mostly using the strength of these screws to actually hold this onto the 2x4. The mount to which I'm relying on the plastic is relatively little, so. And then this is a little bit awkward to tighten. I figured that if you really needed to, you could use a flat-bladed screwdriver to push on these little ridges, but it also didn't seem like it needed to be that tight, so. All right, well that's good. Let's take this off again and go back to maybe doing some wiring, or putting electronic parts in at least. Oh, WD-40, that's a good idea too. What can't it do? All right, well, I guess it makes sense to take the little red thing off, but it can certainly hang out in the wall mount bracket when you're not using it. All right. Well, that's that. What is next for the assembly? Oh, is our puddle of glue fully cured over here? Mostly. It's not fully cured, but it's cured enough that I'm not quite in danger of getting it on my hands if I just put my hand there. Maybe I'll still cover it a little. Okay, well, I think the next things to work on are like mounting circuit boards in here. Okay, so those wires, get those as out of the way as they're gonna get. So, these 3 holes are for heat set inserts. Let's maybe do those next. I'm also deboogering this a little bit. Oh yeah, adding water to the screw and then having it rust in place, that sounds bad too. I agree. Not the intended way for it to work. Okay, let's heat up the bad soldering iron tip and put some of these inserts in. So I think often the problem I have with these inserts is that I end up getting plastic debris inside of the insert because of, if you just like stick it on the end of the soldering iron and then stick it in, then it'll usually kind of cause the plastic to ooze up into the threads. So I want to try to avoid that. I think maybe just holding it with some tweezers and then pushing it with the soldering iron might be more what I want. Oh, also, you can hold them with tweezers by the inside diameter. Maybe that's what I'll do. All right, I think this is warm. Maybe I want to just heat this for a while before even trying to put it in. This is kind of working. I still get plastic oozing up into the middle. Where did that even come from? I don't know about this. The thing that seems to happen is that the plastic wants to kind of pull away from the little bumps in the brass that are actually trying to hold it all in place. So yeah, you can kind of see a gap there, which is not ideal. I don't know, that might be fine. I'm trying to use the screw here to set the angle as it cools. Okay, well, again, I don't know if that's actually really good, but I think it's probably good enough to hold the circuit board in. So let's do that again 2 more times. I'm using the tweezers to kind of push the molten plastic back in the middle, which seems to be helping. And then oh, that screw's too long. And then I'm just trying to set it perpendicular to the surface. That was a thumb screw, apropos of nothing. Okay, one more while that one cools. Oh, there are two more of these on the other side too, which we might as well do now. The motor driver board's held in by these also. I've seen people put these in, and I've done it myself before just by putting them on the end of the soldering iron. This is my attempt at trying to have less debris in the middle of the hole, because I think that in the past that technique would end up getting junk on the screw threads. But I still don't know how much it actually helps, if any. This is an experiment. Okay, that's fine. Next side. So this side has two more. Oh, that's neat. I just noticed the picture that Fred posted in chat. That looks like just a different kind of soldering iron tip for the kind of cheap, not very well regulated soldering irons. And yeah, that would be useful. That maybe is something I could make on my little mill. Seems all right. Little bit of, I don't know, it's like on the right side, some of the hot plastic kind of oozed and buckled a little bit, but I think it'll be fine. push towards perpendicular. Should be fine. Okay, let that cool on that side, and let's go back to the other side. So these screws probably want to be really small. Is M3x8 the smallest thing I have? Oh, didn't I just order some M3x6s? Should try to find those. Chico's sitting on top of my nail. Okay, I think I have M3x6 around here somewhere, but let's try M3x8 because I know I have them right here. If these are too big, I'll have to go find the other ones. Anyway, so this is how we get our externally facing Ethernet jack. That goes in there, just like that. Oh, I bet my coffee's cold again. So I think part of the problem here is even though the holes I left are pretty big, there's like some gooey plastic. Oh, maybe I'm pushing past it. Okay. I think the M3x8s are good. I was worried that those wouldn't fit, but I think we're good so far. Let's see if I can put a couple more in. One down here. This is where I'm discovering the slight misalignment of all my heated inserts. Yeah, let's loosen this one and then tighten them all together. That is not a good angle. This is also certainly not the most convenient place for these screws to be. These are a little bit misaligned, like the whole board wants to rotate a couple degrees clockwise. Maybe this screw is the one that's off. Let's try putting the other two in first. Did I not quite leave enough room at this left edge? It looks fine. But that would explain this alignment problem. Now I'm trying to wedge this screw in at just the right angle without cross-threading it. Yeah, maybe I heat those up again and nudge them just a little bit to the right. There's also what looks like some more debris in the centers of those two bottom bolts. Oh, and I guess I need to reboot the chat. Oh, nice, USB ghosts. So I'm trying to nudge these over a little bit. And then I might just put the circuit board in while they're still kind of warm so that I can tweak the positions. Okay. I can't really get these started with the ball driver. Maybe the fingers are how you get these started. This is just acting like there could really use to be another millimeter of clearance on the left side. Maybe not even, no, millimeter is too much. Maybe like half a millimeter would be plenty. Oh, you know, maybe I can use the soldering iron through the circuit board. Actually, the bottom left one looks like it's pretty well lined up. That's not. It was starting to turn the insert, I think. It felt like either threads are a little damaged or there's plastic in there. Maybe there's plastic in there. It's really hard to keep these inserts clean. See, doing that without the board in place and ready to go seems not so useful, which is why I was thinking about maybe using the soldering iron through the circuit board. But there's also just not that much I can do with these inserts. Like, I can't put the bolt terribly deep into them before it just gets stuck on plastic gunge. Now I'm just trying to get the bolt to attach to the nut so that I can try to pull it out. It's deep enough in there that maybe I'm not as worried about it just coming out by itself. But I don't think the position's quite right. Oh, this is just sad. There's plastic gunge on the inside. Maybe I can pick that off with the tweezers. Depending on how actually bonded it is to the brass. It looks like not very. I'm getting some of it out, actually. Yeah, not all of these holes are blind. The top one actually exits, but the bottom two are. Like, if the bottom holes are pretty bad, I could put a nut in the top hole and rely on that to some extent, but oh, I've got the insert now. Oh yeah, or drilling all the way through to make it not a blind hole. Yeah, I guess that would work too. Card full. Thanks, camera. Okay, yeah. Get out of there. Ah. I mean, I've got room on the other side that I could just drill it out. It wouldn't be that bad. I just keep trying this threaded insert thing, and it keeps not working that well. This one is having a similar problem. James is asking about a device that, like an endless SD card for your camera. Yeah, I've thought about doing that kind of thing. In fact, like I've built an SD card emulator that I thought about using on the camera. I tried it and it looked like I hadn't implemented all the commands that it needed, so there would be a little more engineering work necessary. But that could be nice. I don't know, I haven't been sure how much to invest in making it easier to use this camera versus just assuming I'll upgrade at some point. Because all in all, I don't really need to be recording to SD cards. That's just what the camera I have does. And something with a direct like HDMI or SDI output would be pretty nice. I'd be pretty happy with that. Do I want to take out this last one too and just make them all through holes? Maybe I do. Oh, I mean, there already are SD cards that send the data over Wi-Fi. In fact, I have one. I have one of the old Wi-Fi cards. It's just they're not good. They're really not that good, and they were always kind of okay for video or for photos, but I like using them for video. It would just be so slow. That would be like I would not want Wi-Fi involved in any of my video pipeline. Okay, what's going on with this? This one is having a fine time. Well, it's like I was going to take that one out, but it's actually operating fine. Is it lined up? Let's see if it's lined up. It's lined up enough, I think. Let's try it. I mean, the proof is in the bolt. Okay, now that I've taken out the other two, this one is actually doing great. Maybe I should just put the other two back in, but try to do a better job. Yeah, okay. I mean, and in fact, even just one screw holds it reasonably well. I just would like to have more screws. You can see the RJ45 looking pretty good back there. Oops. This is not the side it's designed to balance on. I hear you, cat. Yeah. Meow. Okay, well. I mean, it would be easy to just drill all the way through. It's just I didn't want to do that because the other side is not flat. And making it flat, just that led to places I didn't want to go. Like either removing material where I didn't really want to remove material, or adding material where it was already kind of tight. And I just thought I would do it this way. I hear you, Tuco. Oh, Tuco, what are you doing? Yeah. Hey, buddy. It's like he tried to get on the desk, but then didn't realize there was quite as much stuff on it as there was, so he stopped mid-jump. Okay, well, maybe the thing to do here is to just... there's like... none of this plastic is in the location it needs to be in. So I'm starting to think that maybe doing it with the board attached is not terrible, but there's also, like, obviously a chunk of plastic over there that's going to be causing a problem, so I might just try to push it out of the way with the soldering iron. Something like that. Hey, Tuco. Do you want to hang out, Tuco? These holes are now pretty oversized. I'm going to try to get an idea of where the actual screw hole location is relative to the one we have now. It'd be especially cool if I could mark these. So it's pretty far to the right of what we actually have on that one. Yeah, this does not seem likely to be successy. There just is not much plastic, actually. I mean, another thing I could do is basically just have an oversized hole, put the bolt in with some epoxy on it, and then just let the epoxy cure. These are all terrible ideas, though. So I'm trying to push the excess plastic out of the way and also push the insert to the right. This PLA gets very soft. Okay. Let's test fit that before going further. Oh, that's still a little too far to the left. But can I pull it while it's warm? Oh, I think so. That's really close. I'm going to try using the soldering iron again to clear some of the plastic out of the middle and push it to the right a little bit, but it's really close. It's not going to be as strong as if I hadn't taken it out and put it back in, but... Also, I can't get the soldering iron into the middle because of the angles. So I'm just going to heat it up and then use the tweezers to push through the middle. Just trying to kind of melt the plastic around the very edge of the insert so that it stays in a little more. That looks pretty nasty, but it'll be behind the circuit board. All right. Tuco, do you want to play, honey? Oh, that was a... Tuco has now left 2 bolts in my socket set. All right, Tuke, you want to play? I wonder if the other side's going to be any easier. The motor driver doesn't have like an RJ45 kind of constraint, but it does have a slot that it fits into on the bottom. Tuco, I feel you on my leg. The insert is in, but I think there's some plastic behind it that's going to be a problem, so I'm trying to use the insert to heat up the plastic behind it indirectly. Okay. That looks pretty bad, but maybe it'll work. Hey, Tuke, let's play. Hey, Tuke. Is that a bad throw, Tuco? How about this one? It stopped on the carpet square, and Tuco just stops. Let's stop making noise. Yeah, maybe what I should do is just heat up the entire circuit board, including bolts and threaded inserts, and then just stick it on the plastic. I think we can go back to this. It's lining up a little better. Where is the insert relative to the hole there? Okay, I think I've got that one threaded. Oh, these are so annoying. Oh, Tuco, you sure are sharp. Yeah, here. Okay, light at the end of the tunnel, getting brighter. Oh, whoops. I was squishing my ribbon cable a little bit. It's fine. It is fine. My board is fine. Everything's fine. Kind of. Okay, now can I finish this with the ball driver? I think the answer is yes. Yeah! Alright, that's feeling better. Screws for the micro are happy. So, now let's come over here to its sister on the backside. So, another choice to make is whether to disassemble the motor driver that I've got partially assembled and put it in here, or just start with a fresh motor driver. I don't know that it matters that much because we've got to modify all 4 motor drivers eventually anyway. Well, let's start with the one we've already been modifying. So, I just unplugged everything from the microcontroller, and we also earlier today in the stream cut the cables for the motor. And I'm going to undo the wiring for the 24 volts too, so that we have the motor driver all by itself. Power supply aside. And there's one more modification that we'll need to make to this motor driver before we can actually use it here. And this is something I decided during the mechanical design, so I hadn't done it during this earlier electrical test. But I need to take off this header and replace it with individual wires. I decided the header was too big and wasn't worth how much space it was taking. We can also maybe replace this wire with another wire that comes in from the e-stop switch to bring in our 24-volt power. Alright, I'm going to warm up the desoldering and soldering tools. Okay. This wire that we added before is going from the 24-volt input to the DC-DC converter. And I think this is where I want to put the emergency stop switch in. Just kill the low voltage supply, basically. Oh yeah, we were doing tricky things to stuff 2 wires into one hole over here, which I don't think we actually want anymore, so I'm just going to desolder all these wires while we're desoldering. Alright, and the desoldering gun, let's see how long it takes to warm up. Oh, that's already melting solder. Alright. So I'm going to take off everything except the capacitor, basically. So these are labeled battery minus and plus, which are really going to the power supply. Alright. Oh yeah, I recommend these desolderers. They're not that expensive and they work pretty well. I mean, kind of the standard disclaimer where you kind of get what you pay for and it's pretty cheaply made, but like mostly not in ways that matter. Well, these are a little bit still attached. Just poking the pins through because the desolderer didn't quite get them completely loose. Well, not all of them at least. Alright. So there's a decent amount of solder debris that might be easier to take care of right now. Yeah, this spool has a lot of features that might end up looking like faces. Where's my alcohol? Ah, I left my alcohol over there. These wires off the other side. Okay, this is almost ready to start doing mechanical mounting. I think it might be easier to solder some of these big wires after mechanical. Well, yeah, I think it might be because of the way this fits into a slot, but definitely want to solder the logic wires before putting this together. How does that work? Yeah. Okay. Let's use silicone wire. Some of this stuff. This is overkill. 20 gauge is too much. Oh, I forgot I had this. This stuff is beautiful. This is Teflon insulated 24 gauge. Oh yeah, this stuff is great. I have that mostly in black. That's fine. I don't really care that much about color coding right at this moment. So these are going to be headed to the other side of the mechanism. Let's make them a little oversized. I need just 5 wires. There's ground, VCC, 2 PWMs, and 1 enable. I'm currently ignoring the current sense wires, and I'm using 1 GPIO to control both of the enables. Oh, good question from David, who asks, that's a huge capacitor, does it have to be that big? Yeah, I mean, there are other solutions to the problem that I was solving with this big capacitor, but yeah, it is actually helping. It's for storing the energy that comes back from the motor when I'm decelerating. And there are other options for that, like I could just have a circuit that can burn it all off in a diode, but I didn't really think it was worth the additional engineering effort necessary to add that kind of a diode clamp. And so just adding a big capacitor gives that energy a place to go without raising the supply voltage very much. And in the event that that isn't enough and it raises the supply voltage past like 27 volts or so, then I end up hitting a overvoltage cutoff feature in the power supply that just shuts off the input. So I'm still responsible for making sure that, like, without any input power, the worst case mechanical, kinetic energy that my system has is still not going to like raise the capacitor voltage to the point where things are going to get damaged. But I think I've managed to do that. And this is all still kind of a safety fallback. Like in normal operation, I won't be decelerating enough that this is going to be a problem. I'll be both accelerating and decelerating really slowly. So yeah, that's what the capacitor is for. Basically giving me more margin for storing energy in the power supply rails without having to have active circuitry to deal with that. Oh yeah, sorry to Ronnie who joined after the beginning and after the 2-hour buffer. Yeah, it'd be nice if the whole stream was available right away. I wonder what the 2-hour limit really comes from. These holes are mostly clear. There's a little bit of solder debris in there still. I'm skipping the current sense holes. I'm skipping one of the enables, and I'll short the 2 enables together on the backside. And these are the 2 PWMs. I might want to clear out this hole a little more. So yeah, I guess to recap what we've been doing so far, this has all been assembling and debugging the mechanical parts that have come out of all the CAD work over the last days and weeks. And so I've got the CAD pretty much done, and now it's just trying to put all of everything together and trying to work around all the bugs that no doubtedly are in the CAD design. Let's see. I think on this side I just want to stick them down with some blue tack. All right. Something like that. I keep brushing my arm up against something that's like strangely warm. And I'm like, oh no, something shouldn't be that warm, right? But it's the power supply for the studio lights. I'm like, actually, that's fine. Oh. Can I get this on camera? It's nice to use the silicone wire for this because I don't have to worry so much about the insulation pulling back and no longer insulating. That one, did I lose a VCC pad? Hard to tell. I'm gonna have to take a close look at that after I get the blue tack off, because I don't know that there's still a pad under where the VCC goes, which could be a problem. This is the enable. Okay, and that's the enable going to both places. This blue tack sometimes will leave residue where it's been touching something that got hot. Like it kind of no longer removes cleanly once it's warmed up. It's a little annoying. Give the autofocus a shot again. Okay, that top pad is the one I'm worried about, that top right. Yeah, I don't know about that pad. I think I might be better off attaching that elsewhere. I think the desoldering took that pad off. So let's just hook that up right to the regulator. Okay, just pull test all the wires here. PWM, enable, ground. Okay. So 5 volts can go to the output side of the regulator. Let's tin this. I might want to reinforce this with epoxy too, because I really don't like having wires attached directly to something that's just like hanging off the solder or the ground plane like this. Okay, well I need another going to the left side of that too. I used the 20 gauge wire to the button. You can just have a wire splice though. That's better than trying to get that same wire onto this board, I think. And I could use a different kind of wire, but I like this kind a lot. It'd be nice to use a different color, but I think I only have this in black right now. Also, a lot of these spools are really disorganized. I brought a lot of these with me traveling for workshops, so I think that's why they're a little bit messy. Okay, so this can be pretty short because there's basically just going to be this going to a wire splice, connecting it to the e-stop switch. And then the other end can just go direct. The other end of the e-stop switch can go directly with the power supply. Tuco does have really intense eyes. It's pretty cool when he and I are just hanging out upstairs and just like looking at each other, you know, like animals. It's pretty good. Okay, so I think this needs a little dab of epoxy to cover these 3 connections. I think these wires are all fine. So we've got 24 volts in, 5 volts out, and then all the motor controller logic and ground over here. And I'm not really going to worth doing a fully powered on test with this thing before the epoxy because I don't think that's necessary, but I'm going to at least buzz this out with a meter. I guess it would be easy enough to put 24 volts into this thing and watch the 5 volts come out. Maybe I'll do that. Yeah, that's fine. Active circuitry. There's the ground. Maybe I'll go with the 9 volts instead of the full 24. All right, 9 volts handy. Ground. .952. Cool. I think we're fine. Let's mix up some epoxy. Might as well put a little bit around the around these wires too. I don't really want to put them all into a monolithic heat shrink bundle because that'll make it hard to see which wire is which without the color codes, but I'm just going to tape them together so that they're kind of going in the same direction while I epoxy them. Oh. I might be starting to get low on these mixing cups. Somehow I don't think it would be worth 3D printing them. You can see how my epoxy situation is. The hole in this container is not supposed to be this big, but I had to make the hole bigger to actually get the epoxy out of it because it was starting to solidify. And now it's hard to seal. Oh, thanks for the hint on the Romanian troll, apparently. Okay. Yeah, this epoxy is getting a little thick. It's kind of like a little epoxy turd. Alright. What I'm really trying to get is the interface between the wires and the board. And that'll be enough. Okay. And try not to disturb that much while it's curing. So where does that go? goes up here. Yeah, I think we can do it this way. I've only ever put it in from the bottom up, but I think now that I've taken the header off, it should work this way if I'm careful. I'm gonna get the board in the slots. Solder joints we just added, seam clear. Oh, that epoxy is starting to flow. I shouldn't let it flow much. All right. Also possible it might be easier if I cut this really sharp edge off. Maybe with a different tool. This little burr is a problem. I think that must have just not quite reached the edge before. Also, can we lay this down this way so the epoxy is not flowing in a direction I don't want it to? Yeah. It's going to be a little hard to tell which board or which wire is which, but I think I can manage. Worst case, I can easily test it and find out. This might be another slightly misaligned insert on the left here. Ah, did I just get epoxy on my hand? Only slightly. Okay, that one's great, I think. Let's get it all the way in. I did get a little epoxy on my hand. Yeah, that's nice. And on the left side, maybe I'm just gonna nudge that with the soldering iron until it's lined up. That looks better. I don't want to put the screw into that quite yet because it's going to need to cool. Although, well, I don't want to put a lot of pressure on it, but if I line it up right now, that could be nice actually. It might be cooling faster than I'm imagining it. Oh yeah, let's do that. Yeah, okay. Yeah, great, that's the motor driver. And the power supply. DC converter is sticking up over there just like in the CAD. Okay, we can also maybe elastic this capacitor down. I have a bunch of RTV silicone, so maybe I'll just get some of that. Didn't really want to... Oh, this one's empty too. Okay. Maybe I'm opening a new tube. That's fine. Oh, that's right. This thing has a cutter and a foil poker. Ooh, look at that. Exactly the right tool for the job, kind of. I want more pressing this down though. Maybe I'll put a temporary zip tie around this. Yeah. And like a little piece of material to press on the top of this. Man, this stuff sure does give off a strong vinegar smell when it's curing. Maybe... Oh, this little silicone mixing thing might be about the right size. Well, maybe I don't need any extra spacer, actually. I was a little worried about the zip tie pressing on the capacitor in just one spot, but I think this is going to be pretty gentle. If it even fits. Am I going to have to use 2 zip ties? You know, the zip tie isn't even really latched, but that's holding it well enough for this to sit all the way down at least. Maybe we're fine. Can I get any more of this in a useful hold down location? Not with that tool. Maybe with a stick. Sure. That seems fine. I don't think that's going anywhere. Oh yeah, this is like bathroom style RTV silicone. I have a whole bunch of that. And it's super cheap and super versatile. It's tempting to put some under here maybe, but maybe I'll try to do that. Then again, it's already proving to be stuck reasonably well in there. Okay, I'll put a little dab in the back there. Okay, I think I will try to zip tie that down. I might just use a bunch of zip ties. Yeah, this kind. Oh yeah, now I've got Teflon and silicone on my fingers. Okay, so these zip ties are temporary. I don't really want to press on the capacitor that much in the long term, so I don't want to hold it in with just zip ties. I don't really want, and I'm not going to have room up here really, because that's kind of where I'm putting the shell of this whole robot. But yeah, that should be enough. Hold it down while it dries. This stuff also makes a great LED diffuser. And it's kind of like playing with frosting. Like, it looks like it should be so tasty, right? Okay. It's tempting just to like get in there and make the texture less bad. All right. All right, let's leave that alone for a bit. So that has some glue that's drying. I don't want to disturb it too much. Well, right here is the IEC inlet, which we can do something with. Yeah, this stuff is not two-part. This stuff cures using moisture in the air. It gives off basically vinegar, like acetic acid, as it cures. Okay, so here's the IEC inlet. For this, I might as well use some of that 16 gauge silicone I have because it's thick and sturdy, and like you just don't want anything going wrong with your mains wiring. And I have some of that right here, so let's use that. And as usual, I don't have multiple colors, I just have all white. We could color code it with little heat shrink doodads on the other end, which is maybe what I'll do. And so this goes to the power supply. The power supply is going to be kind of roughly over here. So 3 of these. Now that we're not relying on the e-stop to switch the mains, all 3 of these are going directly to the power supply. Not that much point adding a fuse since the power supply has got its own fuse. Oh yeah, Treehouse asks if I think it looks so much like frosting, why not taste it? I don't know that I've ever tasted it, although the smell enough is kind of enough to make me not want to taste it. Okay. So this would have been a lot easier to do before mounting it, but this is what I did. And I did do this somewhat on purpose, like I wanted to make sure I wasn't getting myself stuck with an unmaintainable connector. So I wanted to make sure that I left enough room that I could be doing the wiring with the connector in place. But it would certainly be faster to have wired the connector and then just stuck it in there. And I will heat shrink these. Maybe it makes sense to just do them one at a time then. That one's pretty deep in there. And I don't remember off the top of my head which one's hot and which one's neutral. I'd have to look it up again. Okay. That seems fine. Let's give it a pull test after it's cooled for a few seconds. Oh yeah. That is quite soldered. Let's see how hard it is to get that insulated. This might be a good time to look at the color codes actually. Which one is that? It's usually nice when it's labeled. I don't think any of these plugs actually have it labeled, so I'm gonna have to look it up. Was that the neutral? Yeah, I think that's neutral. Okay. Well, in that case, clear insulation. Maybe yellow. I don't have white. I don't know how much that's actually going to help. Let's at least cut that in half. I also don't know how much I can actually shrink this given all this plastic, but let's try it. Let's experiment. Oh, that was a pile of M3 nuts going everywhere. Alright, there goes nothing. Oops, let's see. You know, I don't know about this heat shrink, because I don't really have enough room to put this on especially well. There's also pretty much nothing for this to short out against. Let's see if that does anything useful. Kinda. Alright. Let's do more like that. Where's my other wires? Here they are. This is definitely not something I would want to rely on a bunch of people doing correctly during mass production, for sure. Let's put a little more on. Okay, cool. That's my ground. Nice and groundy. Don't even really need to insulate the ground, of course. Might as well just put some on. Do I have any green? I don't have any large green. Yeah, there's no reason to put something on the ground. I'm just gonna go right to the hot, and I have some black heat shrink tubing for that. The hot lead exactly where you don't want little random strands flying away. This kit of heat shrink I got off of eBay recently is not nearly as good as the kind I'm used to, which I got from Fry's ages ago. All the heat shrink is really thin, and it doesn't have a great selection of colors and sizes. Alright, let's try that. Nicholas says it creates all the fillets that Fusion's been unable to compute. Yeah, pretty much. It's alright as long as you don't aim the heat gun at the PLA for very long, I think. Like that. I think that does fine. Got silicone on my fingers. Of course I do. Okay, and then a little zip tie maybe? My fingers are too slippery. Okay, that'll be fine. That doesn't need to be tight, nor should it be. Great. So those can just go to the power supply. Okay, is there anything else we can do here? I feel like I've already kind of gotten into the, like, I've been doing this for so long, let's just throw stuff at it kind of phase of it, but I don't know, things are still going all right. I got a little touch and go there with the threaded inserts, but so this needs to set. What else is next? Once we can turn this over, I think the next step is just wiring up the electronics. Once I go get the PLA from the mailroom or the post office or wherever it is, then I can actually start printing the shell. Oh, Nicholas says they wanted to suggest a Sharpie to color code the wires. Yeah, I mean, I could. It's just, it might as well. I mean, they're just so big. Like, they're pretty easy to pick apart. And I'll just use the multimeter later, probably, just to be sure. I guess we can look at how the power supply attaches without turning this over. Here's the power supply. Oh, I also need to find those M3x6mm screws, because that should be what I need for the power supply. I think 8mm might be a little too long. And that screwdriver's too big. Yeah, now I'm just losing tools. There was another screwdriver here. Anyway, if I don't worry about the fasteners and just try to position this anyway. So... basically like that. Just enough room. So power supply on the bottom, more mounting on the back. Yeah, I don't want to turn this over too much, but that's pretty much it. And then so these attach with really long screws. These attach with kind of short screws, more short screws. Well, I think that's probably a good time to wrap up the stream. I can finish my coffee and clean up my desk a little bit and let some of this glue dry before moving on to the next step. But yeah, I hope if you were interested in that, that gave you a bit of a feel for what it's been like building and assembling all these experimental robot parts. And yeah, as usual, thanks for tuning in, and a special thanks to everyone who helps out by sending hardware and hanging out with me while I build hardware and doing other things that involve hardware. It's all pretty hardware-y these days, isn't it? But yeah, I will go find the rest of my filament and screws and get back to assembling this. And yeah, I need to figure out what to do with these wall mount brackets, because, like, this is fine, but I'll probably put together some kind of little test stand out of 2x4s that is a little easier than just trying to hold this. So, and yeah, easy to put one of these screws too deep into the plastic apparently, but other than that, it's been a pretty alright 3D print. Maybe I'll leave you with a little bit of Tuco while I wash the silicone off my hands. Thanks for tuning in, everyone. We will see you next time.